about pop out. Yep, that. We got both chats. All right. That one, this one, and then we got that one. My one viewer, my my singular viewer. Oh, and let's do the end command before I mess up. Got to go for Tuesday. I'm going to be around this holiday season, so there will be streams. Maybe we can get some people we rarely see in here. Hit com. Nobody uses the next command, so I don't really, I kind of undid the responsibilities of that one. No need to update that. So I'm going to be back. The next stream is going to be Tuesday the 17th. It's really only the 14th. Feels like the holiday season is here already. 1/7. That's December. Yeah, okay, there we go. Cool, got it. How's it going, Mahalo? How you doing? I did some desperate. I don't know if people saw the skeet, I guess we call them. Whoa, I was there like a ton of. My bitrate like crashed there. What happened? I guess my bitrate is fine. It was the OBS. Are we dropping frames? 32% CPU from. I think I need to build a machine for this for the stream. Yeah, so desperate times called for desperate headers. So I soldered the knobs down so that they will be attached to the board and able to be tested with until this design comes to fruition. Yeah, so those will be all right. Those will be pretty good. Of course, we're using the other style for the final thing. The other style is the ones with the really long tips, and they're kind of more narrow. Long knobs, that's what I mean. The ones that have built-in long knobs and all that good stuff. Yep. Yeah, I did not stream yesterday. Just you know what? Can't do it. Gonna do a Saturday. So today I'm feeling much better, able to stream, able to get you guys some much needed end game content here. Well, endish game. This is sort of end game for the stage, which is the breadboarding stage. Hopefully we can get the 3 knobs controlling our final mix that goes to the headphone amp, and we can figure out what we need to do after that headphone amp in order to keep our audio in phase and at the right levels for everything. And if it's down to getting a specific resistor, we won't sweat that because I can just do that on the PCB when that comes in. I got these little protection guys. Didn't make it into any of the circuits yet. There's a debate about what I need to incorporate into this design, if I need to have all kinds of safety stuff and temperature compensation. I think maybe I won't do temperature compensation. If I did, I could tout it as one of the main features of the device. And then the other thing I'm debating about is whether or not I need to wear suspenders. I don't know. You think I'd do the suspenders outside of the shirt look for the big fat guy? That might be in my future. I may have to do that. What's up, Madam? How you doing on YouTube? You're not hearing any music because you're on YouTube. I saw Sark is streaming, and he did a whole musical bit using, I forget what song it was. It was like some famous song. He did a whole bit with it, and then at the end of the bit, he's like, if you're on YouTube, you just heard silence for the past 5 minutes. Dallas house music. Is this isn't my cousin, is it? How's it going? Digital audio workstation, less house music. How do you know it's house music? I'll tell you. I'll let you know. They're good like that. They say, hey, by the way, you're listening to house music. You're like, oh, okay, thank you. Appreciate that. You can't hear the music, actually, Dallas, because you're on YouTube. Again, the YouTubers do not get the music that I play only during the intros. Only during the intros. We're a musicless stream otherwise. Wait, what did... Oh, yeah, no, we're up to date. We're up to date. I got both my chats here. Sorry, rearranging that third monitor. You get 3 monitors, and all of a sudden, all your projects expand to all of them, and everything is, you know, like I've got a video monitor window with a lot of wasted space on it, actually, but I guess I'm using that space to monitor my audio, which doesn't really even need monitoring. I could make the OBS window a lot larger, or I could do it as some kind of a studio view so that I can queue up shots ahead of time. But like, I don't know, I just click on the scene over here in the bottom corner, and then I see what I'm doing over there, like the microscope and stuff is on that window. Then over here, I try to populate all of my moderation stuff, so I get to see, hey, wait, why is there, oh, this one's the one that lets me moderate. This one is the one that actually goes to the dual chat that you see on screen, and then this is the pop out from Twitch that goes to the dual chat on screen. It's a whole thing. But yeah, those are useless. Those are useless. Just this stuff. And then all the way over here, I have what's being broadcast. This is what actually goes up on Twitch when I do the side monitor view, and then I have a dual chat right here, so I can see messages rolling in. I don't see events on this, which is why I sometimes miss events. But yep, there's a piece of metal right there. Oh man, so I had a sandwich for lunch. Believe it or not, I had a sandwich for lunch, and it was on an Amoroso roll. And the real awesome way to do the Amoroso roll, no matter what you're making, is to toast the roll and then get some butter on it, just a little bit, a little tiny bit of butter on that roll. What's up, Hairbothan? And that just makes the Amoroso delicious. The only problem is what it does as well is it makes the outside of the roll flaky, and so I've like roughed up the roof of my mouth eating that bun. I could feel it. It's that kind of like raw feeling at the top of your mouth. Ah, I made a mistake. Let me get some liquids. Maybe that'll help. I sit in front of this pile of garbage and basically yell at it for a while. And that's my stream. We're going to work on the mixer circuit today. We're going to poke around with some waveforms. Oh, speaking of which, just remind myself to turn on the Dusty Scope. We do need to put a 120 millimeter fan on this thing. I'm afraid for its longevity. I'm afraid for its longevity in that its heat cycle's pretty strong every time you turn it on and off. And then we'll have to do our 2 AutoCAD ads this month. Or at least, well, we'll have one soon with the PCB design. I think we'll have one pretty soon. What be going on? Not much. We're just starting off. Just getting rolling here. I gotta get myself in a stream mood. I don't have any ADHD medication, and I don't have caffeine. So this will be fun. It'll be a chill session. It'll be a chill session. I had to clean this off. This thing has like spots on it. One sec. It takes me a long time to sign into Twitch. Mine's just like automatic, but whenever it needs me to actually sign in, it takes me forever because I have to get all the credentials and all the 2-factor authentications and blah, blah, blah. Yeah. So I don't doubt it. I don't doubt it takes a while. Metamucil is legit. Did you get a cold? I don't think I've ever used Metamucil. And I haven't used Alka-Seltzer. Ah! Eh. You just throw some Windex on my wind tube. This thing was sent in by, I forget. No, I do know who it is. I just can't remember the precise screen name at the moment. Well, they sent a lot of stuff in, but this is just a printout of the vectorized Bother logo. There might be a listening device inside of it. I've never looked. I never actually looked. There might be a secret compartment inside. My digital assistant? No idea. I need to set up Nightbot a little bit and set up some things that maybe some of you aren't gonna like. But due to what happened last stream, this is why I haven't cleaned this, is that there's a lot of nooks and crannies in this stupid thing. Collected a lot of dust. I should print out my own. I don't want to buy all the filaments, though. This is like a lot of filament went into this thing. See, I wonder if I could get like a spudger in there and pull this out. Check for a listening device inside of it. Like, oh my god, there's a listening device. A toothbrush might clean it up a little bit. Oh, it's good enough. I like to put stuff like that in the background. It's not really a pharmacist thing, it's a pre-approval thing, and I don't know if my doctor bothered to submit the pre-approval stuff. They usually are pretty good about it, but then they're terrible at communication. I don't know why they don't communicate anything. And they said 7 to 12 days, and I haven't been counting the days, but I think we're at 12 or beyond it. I am petrified about whether the internet will ridicule or ignore if I start wearing suspenders. If they see a suspender strap on camera, am I going to get castigated, made fun of, ridiculed, or ignored? I'm hoping for the latter. I'm hoping for the complete ignoring of the fat guy look that I would be taking on. The belt that I bought this belt. It's an expensive belt. It's got a magnet in it, so I just have to get the two buckles near each other, and it's like clunk, and it like latches in. It's so awesome. So I can just be like, bam, pants are gone. But the thing is, like, the design of the belt relied on there being sharp edges where the belt strap comes in and loops around. So without sharp edges in that area, it just loosens. And so I loved the belt until the version where the tooling wore down and it wasn't sharp anymore. And so now the thing just loosens on me. And I was like, I need a solution for this. And I'm like, straps. We'll just wear suspenders that'll just hold my pants up at all times, and then I don't have to think about it anymore. And it works pretty well, to be honest. It works pretty well. My pants aren't falling down all the time anymore, and I don't have to keep tightening my stupid thing. You could rock suspenders? I guess so, but it's going to look more like, I don't know, it'd be like I'm wearing a harness. And then I have to tuck in my shirt, which I guess isn't that big of a deal. It probably looks pretty dumpy without me tucking in the shirts. With the shirts loose on my body, it looks like somebody put a tablecloth over a beach ball. So I guess, yeah, it's a look, and maybe I need to lean into it a little bit. That's probably something I need to do. Dress for the body you have, right? My body happens to be Santa Claus, so maybe I should dress like Santa Claus. And then the continued graying of my beard hair will take over, because we've got kind of a whisker. We got a little bit down here, but that's always been a little salt and pepper. But the rest of my beard can follow, and I can be one of these gray beard shop guys. Let's go over to the middle. I need to be thin. I need to be a thin weird beard. I don't want to be the fat weird beard. Those are the chips that have been handed over to me. The suspenders become a trademark. I don't want the fashion thing to be more Gandalf style. Yeah, exactly. More of the oh ho 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 instead of the oh ho ho ho. They all sound the same. They all sound like oh ho dome. I don't know, man. Yeah, go wizard instead of dwarf. I'd have to diggy hole until my beard becomes gray, and then I can just ride a sleigh. If your beard grays but your hair stays, you could always say you're Gabe Newell. All praise. I'm the Gaben. You know, the guy with suspenders. Oh no. Then I have to get like fancy ones. Gotta get ones with like circuits on them or something. Get some high-vis neon and reflective suspenders, and everyone will ignore them. Just take one step out onto the road and every car is careening in my direction. I'd be leaning into that Coca-Cola IP and therefore automatically get popularity. I feel like drinking a Coke when I watch this channel. Weird. Abercrombie belt that had a silver 1/4 raised embossed Abercrombie on the top of the buckle. It always ended the day with Abercrombie on my belt, or Eberkerber, because it's the inverse. That sucks. Yeah, see, I don't really have huge hips, but I had enough that it would hold up my pants. If my belt would stay taut, it would hold my pants under my belly, and that would be fine. But it turns out it's not the best, and this new belt is not doing its job. So I was constantly losing my pants. I would be like going on walks with Willow and like pulling up all kinds of different appendages, all kinds of different, you know, fitments of my pants around my hips, and so I got under the shirt suspenders, and it's been a transition to say the least. I just don't have to think about it anymore. So I'm like, well, right now I kind of look like like a balloon with like a sheet over it, right? I look like a balloon with a piece of tablecloth over top of it. And so it's like, what should I lean into the that I have a perfectly round belly? And it's like a cliche like wood shop guy is basically what I'd be leaning into fashion wise. I don't know. I could probably pull it off. I would need to get different suspenders because the under the shirt ones are wide. They're very wide. Santa Claus image is created by Coca-Cola. Oh yeah, these are all the same messages. Nobody said anything. That's an idea. Yep. Okay. I've read everything. Sorry. The machinations of a streamer about to go through a circuit. I don't know. It's a thought. What's going on around here? Let's see. Up to date with everything? I'm up to date with everything. It's a Saturday stream, so we're not gonna get that many people here. It's gonna be fewer people typically on the weekends, because many of my viewers are, believe it or not, people who actually work with this kind of stuff and want to have something that's fun up on the screen, but don't want to out themselves as being distracted. So they'll put this up on another monitor and do other kinds of work while I do other kinds of work. It's a system that some people use, and it brings me quite a few viewers, actually. There's quite a few people that have outed themselves as doing this. Too big. I don't want the action end of the hammer to be a handmer. Oh, all the weight's up here. Oh yeah, I remember this song. No, that didn't work. It's a very Big John kind of track. Nah, it doesn't work. What else? Is that Depeche Mode? Sounds like them. Give it that. I'll give it that. Tune. I don't have, no, none of this stuff is digitally connected. I don't like digitally connecting things. I know a lot of streamers have some pretty crazy setups, and I need to learn some of these other streamers' setups and how they automate all of this different stuff. It's probably services that want to scrape off money. But this is Big John from Philadelphia. It's a big mix from District in August 28th, 2021. It's actually relatively new. But the Depeche Mode thing is a song that I've heard Big John throw into mixes all the time. But there's not even a track listing. More. Oh, no. There's not even a track listing in the description here. He's wearing shop pants. See, he's got the shoulder strap look going on there too. He's wearing but he's wearing the smock thing, whatever you call it, suspenders. No, but that's different. It's the whole shop look, which is another thought. I could probably pull that off and I would look less fat. I don't know. Oh, he's a lot thinner than I am. I need that physique. I need to hit the gym is what I really need to do. This is the suspenders are kind of putting a band-aid over an image problem that I have on just putting up weight, you know, since fucking 4 years ago. I'm not even supposed to be here today. Yeah. We're talking about whether or not I should lean into the suspenders look, and probably as a result, I would end up going full Santa Claus when everything grays up around here. I don't know if I could pull it off or if I'd get ridiculed for it. Really what I need to do is like just not eat. I need to just not eat for like a couple years. Full Al Borland. Yeah, see, there's the problem. Yeah, it would go full Sinterklaas in like only a couple of years. I got a couple of years left before everything goes gray. We got a little bit of gray here and then a little bit of gray going on around here. And then every now and then one of these will come out white. So I think I got a little while until it goes full gray, but I don't know if I have that long. So, but then if I go suspenders and the white beard, and it's just not, that may not be good. Maybe a little bit too, you know, I was in an airport once and it was around this time of year and one of the guys there was full up Santa getup and he's like, "Why aren't you doing this?" And I'm like, "What?" What? Really? How do you respond to that? I said, "I'm not going to go gray." I just told him that. And I might not. There's a chance though. I've been seeing that the writing is on the wall. I don't think I'm going to fully look like Julian does. Julian went way gray, but that's I guess the Russian genes in him. But I don't know if I will or not. My grandpa did not really have gray hair. Big John from Philadelphia, United States, just got another follow on SoundCloud. Nice. Hey, you know, he does mixes periodically. He's not well, I don't want to say he's not something, but I think he's moderately, you know, he gets good gigs. But I don't know how often he's going to be updating SoundCloud. I think there's other places that he populates. There was a time in the past where gray hairs started to show up, and then I guess I didn't seem to have them 5 to 10 years ago. There are certain milestones when aging, when the body ages a little bit more than usual. So you go to like, I think 44 was one of them. So I'm off of that a little bit, but we'll see how things go. So I modified potentiometers, and now they fit on the proto board without moving around. I had to give in and put 1,000 headers on them in order to get them to stick. Even still, the potentiometer's fighting me. All these dimensions are weird. Like here, there. Now it's straight up and down, but I don't think it'll fit in the spacing of the holes. Yeah, it doesn't quite fit. These are useful. When you need a bunch of them, it's annoying, but it's useful to have these able to lock into the proto board and not move around. We're trying to be professionals about the circuit, and so I'm trying to realize the entire circuit all at once with all the correct values in here. Why didn't that? Oh, there it is. Now it populated. I stuck a few in a board with leads for breadboarding so I don't ruin my boards. Yeah, when you try to... I even tried the trick where you twist the pins, which is the only reason I have this specific very gonadish plier here. This is the gonad style of it's. I don't think he can claim it as his own, but I'm gonna claim it for him as his own. Where you pinch the wire in flat pliers, then you crimp over it, and you simply twist these, and it pulls out the crimp, and you don't have to like kill your fingertips or your wrists or anything doing it. But I grabbed these flat pliers, very useful in a shop like this, the needle nose flat pliers, to take the leads that are typically facing this way, grab them, and then twist them this way. And that way, the clips of the breadboard fit in neatly. They're in a little front panel thing, so I don't use up my breadboard space. I may buy a breadboard just for the fragile breadboard stuff. I was thinking about that today, like things like this and things like the headphone amplifier. Like this thing will not survive in my little fishing lure bins. This will not survive in that. This barely survives here on the breadboard. So I may put it into a breadboard that I keep breadboard stuff like this around with. What's up, Ultimate Mall Ninja? How you doing? It's been a minute. I used to just chew off the plastic. I did that too. I think that's why there's like a perfect 18 gauge like chip in my front teeth. Music's a bit loud. Oh yeah, I see that. SoundCloud is a little louder than YouTube. Sorry. That's pretty much why there is a 18 gauge crimp socket in the front of my face. Because I always just But then I also tried to one-up Gonad on his method by getting one of these things. I have a feeling he would get a lot of use out of something like this. Because it's got the wire cutter here, and then this pulls and lets go all in one operation. Ivory crimpers, yeah. I've done that to my front teeth as well. I think I've crimped something with my front teeth. I think I've done that before too. It's not a good scene. When you're a teenager, you think you're gonna, survive everything, but I don't know. I like this thing. The only time I would use something like this is doing the kind of stuff that Gonad does, and he very much prefers pinch wire and then do the little pull operation that way, because it's just that much easier. Yeah, if there are lots of like wire ends that you have to put onto something, I don't find myself doing that a lot, to be honest. And I was actually using the Gonad method when I was making these custom length wires for the breadboard. The breadboard. I had a googly eye on this thing, but it fell off. I can't maintain it. The way I use my tools, I'm grabbing them every which way and like pinching myself with them in weird and unique ways. So googly eyes just don't stick around. I have a big thing of them though. Three Mares made sure to send me a bunch of googly eye stuff. Actually, we should find the giant googly eyes because those should go over there. I should get some better tape on them. Let's figure this out right now. Of course, that means that my big dumpy body is going to be on camera, which I don't appreciate. Okay, here's one. Whoa, lighting stand. When I have my lighting stand belaying for me with the microphone cable. That way it keeps it from getting under the stool. Because it kept getting under the stool and I kept unplugging myself. Okay, this is one. These, I fear these are too big. I kind of wish they would, I need them to like bounce around when we're using the mill. There's a huge adhesive on the back. All right, hold on. See if we can find the other one. It's somewhere over here. In this giant mess. Actually, what I think happened is it fell down there somewhere. Oh, there's that one. I'm not going to find it until I really clean out the shop. Let's see. One big googly eye. I think it's been lost to the wind. And I need to find that kit of googly eyes. I don't know where those went. That I put somewhere and just promptly forgot about the location. I have one singular eye. The other one is probably smashed up against the wall somewhere. Likely behind this thing. Because I had them up top on the tool chest. All right, I'm going to look way under this and see if we can find that googly eye. Because I think they slid. There's a door that's open on top of the tool chest, and I put them above that door. I have that size on my fridge. It's like, where else do you put them? Ow. Owie. Owie. No, it's not behind. So if it's still there, then it's going to be directly behind the wooden chest. This has been a great upgrade, by the way. These two. Because this I can put all of my like circuit testing stuff in. And then this is all of my overflow of tools. So if I need a specialty tool, I go into the wooden chest, but if I need a circuit testing thing, it's kept out of the dust. I don't see them. All right, so we got a Cyclops. I need a giant eye patch then. I guess I'll just put this up here for now then. If I can't find the other one, there's no point in googly eyeing something with one googly eye. That's just not gonna happen. We're not gonna stoop that low. There's nothing over here. Okay. Can't find it. Don't know where it is. I do not know where those googly eyes went. I had a whole package of them. That was a lot of googly eyes. I could significantly googly eye my shop. I gotta think about what happened to it. It was a whole kit, and it had every size. But yeah, I need to find a place to store these little things, because this is a truly tiny headphone amplifier and probably won't survive very long after having been breadboard adapted. Trying to think of where that thing would have gone. Set of googly, maybe it's down there. That's an odd place because that's sort of like a saws. That's mainly a support drawer for the milling machine. So I don't think it would. You know, it might be in the main, the big wooden tool chest somewhere, or behind. There's some like weird storage stuff that I have going on behind here. There's like a whole robotics controller that has two really nice RC XY axis control inputs on it. Like they're Japanese. They're really, really good. I should put those in something. I should make controllers. I've got all this stuff for controllers. We do need to do like a little bit of work with computer controller input stuff, because I've got everything for the two controller joystick. I can add the good X65F throttle, which is a really nice throttle, has like a mouse on it and everything, and add all that stuff in to like a singular teensy 4 that would show up as a joystick, like a Supermaster joystick on the computer, and then I could have all these different like interaction stuff. Yeah, I've got a lot of little things like that, and switch panels and stuff that would be very fun to incorporate. I think mainly we put so much effort into making my wireless steering wheel not wireless that it kind of broke me, and I was like, put this stuff aside for a while. But like there's a project in getting all of that stuff amalgamated together. The steering wheel would still be a separate entity just because it has to be. It's on a Granite Devices controller, and I don't want to reinvent the wheel when it comes to servo control and force feedback. I'm sure I can at this point, and it would probably benefit me in a big way, but I've already invested all the money. We had enough money coming in that I went, Granite Devices controller, that's kind of expensive, bonk, buy, and I was just like, burn the subs money, pay for that. So we were able to make a very, very cool system that I kind of can't use until we redesign my desk. When I redesign the desk, it'll have, 20/20 rail. I would like to use 80/20, but I think 20/20 is going to be more economical. It'll have 2 racks. We need to figure out what it'll have, to be honest. But that 20/20 rail will give me mounting points for things like the steering wheel to just kind of like, crunch into and then mount to, and then I've got a nice solid steering wheel in the front of the desk, and I can have pedals that'll clip in and out when I want them to. It means Willow's sleeping areas might be somewhat compromised, but she doesn't use it a ton anyway these days. She comes down and sleeps under there every now and then. I actually think today would be a very good day for her to come down and sleep, but it's because it's very cold outside. She's totally comfortable. She goes out there, she's like, yeah, this is great. I'm gonna chew on a stick. Haha, I'm chewing on a stick. And I'm sitting there in my winter coat like, how are you at all comfortable? It's that undercoat, man. Those dogs with their undercoats. It takes her like probably a half an hour for the heat from inside to get out of the undercoat. And then she's just supplying her own little radiative heat in there. It's kind of incredible because I'm out there like my face hurts. Like It's only going to get colder, colder and colder. We got a lot of work to do, though. We've got a 35-minute intro, which is pretty decent. I'm probably almost out of stuff to talk about, to be honest. And then we need to get this mixer circuit going. Ah, man, that reminds me. Every time I think about this, I need to do thumbnails for these. I need to have, because, you know, we have like a particular project in mind. We don't typically jump around. So if I get a good picture of what I'm trying to build and I give it a title and I put the bother circuit guy down there with doing a reaction emote, then every time I work on this project, boom, there's my thumbnail. I'll put a different bother on it and it'll have all the same text and the same image. And as things slowly change, I can change elements of it, but it would be just a quick little Photoshop, throw it up on the YouTube, everything looks professional. Because YouTube has these thumbnails, Twitch just kind of doesn't do the thumbnail thing. It's a much easier platform. But with those thumbnails, things would look a little bit more professional and I might have a little bit more swing in terms of getting new viewers. It's the whole thing is that YouTube algorithm is very powerful. So we got to lean into it. Okay, yeah, I'm gonna fade the music out. We're gonna get started. You know, making the noise while I fade out the music is not really a good way to do it because then it's just about you making the noise and not actually fading out the music. Hi, how's everybody doing? Welcome to Saturday. It's like some degrees outside, so it's very cold. I still have a fan on me because I am an indomitable fat ass and I just create radiative heat. If I sit in somebody's passenger seat, I will fog their windows during the winter. I don't know what it is about me. I always have to have a breeze on me. I should be a fisherman or something. I don't know. But anyway, I got a fan on indoors. It's dry. It's cold. Let's stay inside. Let's stay inside. Let's work on some circuits. I have a mixer that needs making. Julian, my musician buddy, came to me and he said, you know, it would be really cool. This is in one giant text. He wanted a stereo mixer for the modular synthesizer. So that's a right and a left channel and then another right and a left channel that could be mixed together. And you would use a knob in order to turn up and down either of your right and left channels. The channels could be used individually, but they would be associated with one another because right and right mixing with left and left would go to a right-left output. It would go to a TRS tip ring shield plug. Most of the modular synthesizers in Eurorack anyway, the plugs look like, and I don't have a plug to show. They look like this. That is just a tip and a ring. It's a TR plug. You don't see them called out a lot, but a lot of people outside of modular synthesizers don't use these kinds of plugs. This is a mono 3.5 millimeter plug or 1/8 of an inch. And these are what bring your signals around in a modular synthesizer. Synthesizer doesn't necessarily work in stereo all the time, right? But when you have your sort of output filters, they love to play with stereo. And so as you go through the stages of synthesis, you may end up with a right and a left channel. Maybe you want to mix them together. Maybe you want to just put them in stereo to your output. You have to attenuate that output because the Eurorack synthesizer, audio is typically plus minus 10 volts. That's 20 volts that you can hit into somebody else's thing. And let me tell you, your headphones do not work on those voltages. Your speakers definitely do not work on those voltages. You need to attenuate them way down. So we're going to do the job of attenuation here for an output stage. So we are an attenu mixer that is specific to high quality headphones. It's been a little bit in the making. We've explored these circuits slowly, and I've ordered parts in order to reflect what we want to use in the final thing. I've had to branch out of the typical Eurorack TL07 for you know, the usual chips that you would use and the usual circuits that you would use because of our special application. So now that I have these parts, I've broken them out to the solderless breadboard, which means that we can reconfigure our circuit on the fly. We've gotten through most of our circuit. We've actually got an input to output stage. Because of the way, and again, this is a lot of this leads to this, leads to this, leads to this. It's a narrative, an organic narrative story where things influence the outcome. It's just like gaming. It's just like gaming. But so we've got some of our stages figured out because the mixing works in current and not voltage, we can't directly observe it. We have to have an output stage amplifier that we can drop in and observe it. So this breadboarding has been utterly confusing for everybody else, but it has been completely fascinating to me because we sort of can't see what's going on. So we have an output filter that we're viewing, and then we move what we're viewing in the output filter, and it shows us what's going on. It's crazy. So if you follow, which I know a lot of people don't, because these machinations are all just internal. They're all in my head. And it's hard to bring you guys along the trip. I have a cheap earphone plugged into my PC, and they zap me whenever I put my bare foot on the floor. I have that problem with my chair, and I think it's due to the way the monitors are designed. One sec, I gotta move my microphone. One sec, moving the mic, moving the mic. There, needs to be a little higher up. Is your head in the room with us now? No, it's not. No, it's not. I haven't had my ADHD medication for a month. It's been almost an entire pill cycle. So, no, I've had a lot of trouble working on this thing on my own. We would have been a lot further along now had I the ability to do tasks that were low dopamine. I would have programmed the screen to have a menu on it, and I would have powered through that for the tester. The tester, we needed 4 channels of audio at plus minus 10 volts, so I've had to build an entire tester in the middle of this project just to get this thing sort of off of the ground. Yeah, so anyway, my desk chair has static problems. It's horrible. I need to either spray it with stuff or sew some conductive thread from the top to the bottom and couple them together. Because when I get out of my chair, there's a spark noise, and then my computer screen goes blank and comes back up. And apparently it's a known issue, and people haven't found too many ways to get around it. Mostly it's just running conductive, like some people use wires and take them apart and wrap them around the post of the chair and put that to the back of the chair. I'm going to do that with conductive thread. Okay, anyway, yeah, so what's going on here? So in order to make a mixer, we need to have right channels, and now this is our napkin drawing, so of course it's going to be completely and utterly disgraceful and disorganized. But what we need is we need a mix control, and then we need a right and a left input. So mix 1 is going to be controlled by the 2 inputs to the voltage controlled amplifiers R1 and L1. And so those 2 channels don't come together, but they get controlled together. Same thing for R2 and L2. The problem that faces me with is that, well, those are mixed now. Now, I didn't want to do this with just resistors, right? Like, one way to do it would have been to have your audio coming in, and it would just go to a variable resistor that in some way, I don't know, would mix with your other channel. That is one way to do it. But I wanted to build something that was a little bit more professional. And so I've decided to use these V2164 current controlled amplifiers. That means that each channel gets its own amplifier. And because I could have done 1, 2 into one of these, and then I could have done 3 and 4 into another one, and then you would attenuate that channel using the variable resistor. That may still be on the table, to be honest, to attenuate the channel with a variable resistor. We haven't really figured that out yet. Julian was talking about some kind of a normalization of one of the channels, because that's what the other mixers do. I don't know how they do that. Maybe I could use some kind of a buffer and a gain circuit, but that's more chips. See, the big challenge of this thing was not only that I have to figure out how to make mixer and also how to make audio amplifier and all that stuff. The other piece of it is he wants it in a form factor that is utterly psychotic. He wants it in 1 Eurorack panel. So that means that my PCB, which is in the wrong view mode. Sorry about flashbanging, everybody. River Rubicon is the environment that you want. Oh, that's so much nicer. River Rubicon does not mess up your colors too much. It enables you to see dark things just properly, and it also night modes this a little bit more. Someday we're going to get a night mode for the actual UI on this program, and it might be in this update, I'm not sure. But so anyway, we have 2 stereo channels that you can control individually, and then you have your volume control separately. I still don't know about normalizing right to left, but it has to be in this form factor, which is 10 millimeter, or in our, 10 millimeter by 100 millimeter. I could have done 9 millimeter, and then it would have fit those little clips. I'm going to have to do like a keep out area on these clips here, because I think I'll have to use a microfile and just file that area down just a little bit. Oh boy, this is going to be a shit show. It's going to be crazy. But this is a known form factor. There's a whole company, 2HP, that makes Eurorack modules that are this big. And so you do your minimum functionality. What do I want? A VCO. What do I need for a VCO? I need this, this, and this. And you choose the smallest possible, and you have this little bitty, itty bitty, tiny bit of room on the PCB for all of the electronics functions. It is maddening, but it's kind of fun. The limitations are kind of fun. So I am debating what the total number of amplifiers is going to be on this board. That's where we are right now. That's what we're working on with the actual design of it right now. But so the other stages, if you hadn't inferred already, are that in addition to mixing in 2 channels here, we also need volume control. And apparently doubling up on this chip, doubling up the amplifiers, does something with your signal. It makes it, I don't know, gives you more granularity in the control or something like that. So I'm doing that. I'm doubling them up, paralleling them, and just taking a right and a left mix and giving them the same volume control. So there may need to be something here in order to sort of normalize the volumes. Maybe it's something that I do to calibrate it at the factory. I don't know. And then from there, we have to take it from the current space back into voltage space. So this has to be converted back using this amplifier. Somehow they're telling me that this is not inverting, but I think they mean this is not inverting, but this is inverting. But like, if this is inverting, how can you brag in your data sheet that this is not inverting? Because then you just get inverted audio. That's the thing about audio amplifiers, is if you want to have a large amount of range and you need something to dampen or amplify, you want to have an inverting amplifier setup. If your transfer function, the number that you multiply your input current or your input voltage with in order to get your output voltage, if you want that transfer function to be fractional, go below the signal level, when you do a non-inverting amplifier, the coefficient is 1 plus R2 over R1. And so you've got that 1 plus built in that you kind of can't, you can, I guess you can fraction the 1 off, but it's like you can't significantly lower. It's sort of a diminishing return. So anyway, inverting amplifier is the way to go. It doesn't really work because you're inverting the phase of your audio. Now, if the phase of your audio is inverted, what if you put it on speaker with a non-inverted audio phase? Things get a little bit weird, right? So you want to have your input audio and your output audio to be in the same phase. That's sort of like a tenet of a mixer circuit. It's like the least requirement. And I'm sure some don't do that, but you kind of want to have that. So in order to achieve that, I need to then have another amplifier on the output. And we got to see what that topology is going to look like when we get to it. This stuff here is still kind of a large unknown. When our signal comes out and it gets inverted again to be in phase, does this invert it? Does our headphone amplifier invert it? If it does, then maybe we're just good sending it in inverted, and then it'll revert it. These are the things that audio circuit designers have to think about. But yeah, we can do a non-differential here, or hey, maybe this op-amp's operation is fast enough that we could do a differential on the output. What's the advantage of that, though? I don't know. Maybe less noise? I don't know. I'm not too concerned about noise right now. I am not a professional. I am a hobbyist. And as such, I don't know all of the little ins and outs of the minutia of what we designed for in a circuit like this. I'm just throwing my ideas down, and we're going to see what they're like in the end. How many capacitors am I going to need to put into this thing? We're just going to get our feet wet and do it badly. All right, so let's get our feet wet. So what do we got so far? Well, okay, so I've got 3 of these potentiometers that I just added legs to, And then we have our two values of resistor that will get us the right voltage range to affect these things. They didn't make my job easy. They really did not make my job easy. In order to control these things, these are actually controlled by a voltage level. And the voltage level is from negative 600 volts, millivolts, to 3.3 volts. Why? I mean, if I had a 3.3 volt supply going into this thing, that would be fine. But then negative 600 millivolts? I want these to have a full range. And they're also what are they? They're also exponentially controlled. So I don't know what that's going to mean in terms of like what it sounds like turning up and down volume. It's so frustrating with these guys. This circuit, like, if they put these things into the chips, I would have a much better time. I don't have the real estate to do all of these circuit things that they're requiring here. We're just going to do it and we'll figure it out. Yeah, put the 600 millivolt power supply on it. Is there a minus 600 millivolt voltage reference that I could get? Excuse me, I'm burping. If I had an op amp, if I had $1,000, if I had an inverting op amp, minus, plus, ground, and I had another inverting op amp down here. The only problem with this, okay, so there is still a problem with this. We had one of these here. I'm doing squiggly resistors because they look hideous in MS Paint. And I had this one going to negative 3.3. And then this would be a voltage divider. Same here. So that would be adjustable. The resistor. Jesus, it's looking worse and worse. And then this would have the three controls. And the op amps would provide all the current for them. And then this would be positive. This would be 0.5 volts. Or no, it would be negative 3.3. This would be positive 0.5. I don't know. That would use fewer op amps by only one, whereas the circuit as it is going to be oh Jesus. I better do box resistors. This sketching is this is where I wish I had the pen to be able to sketch these quickly. Resistor, variable resistor, resistor, ground. This here is the volume control. And then that goes into an inverting op amp. Ground, minus 12, plus 12. And then it's actually a 1-to-1 inverting. G is equal to 1. That's the way that I'm thinking of setting it up, and that would be times 3. So I would need 3 of these tuned potentiometers so that they would swing from negative 3v3 to 0.5. This is G is equal to -1, which is hard to see. Hold on. I'll fix it. -1. There you go. G is equal to -1. So the -3.3 becomes positive 3.3, and then 0.5 becomes -0.5, and that gives us I'm saying 0.5 instead of 0.6. It's 0.6, but still, everything is adjustable because you just give it different resistors. And in fact, I have that right here. This is more components, because here I would tune 3.3 and 0.5, whereas here I could tune the individual channels, I guess. I don't know, man. I do not know. This is getting out of my sort of realm of expertise, because I'm not in with all the audio stuff. Those guys have like pulsating brains. They kind of like their brains pulsate. Ah, yes. I've known this since the dawn of time. Silly human. You're doing circuit stuff? I wish I could give you guys that like super duper guru audio input education. Say, yeah, this is the way that I know things are done. No, you guys get me scratching my balls going, I don't know what the fuck's going. So you guys think I could really pull off external suspenders? 29 kiloohms on the one that goes to +12. So this would be 29K. And then the one that goes to -37.5K. But those values will change if we do a temperature compensating circuit. This is where the details pile up and I get kind of overwhelmed. I think maybe we're going to ignore temperature compensation unless it bites us in the foot. Unless we actually get different performance over heat ranges, which, you know, it's 0.3% per degree Celsius. I don't know what the internal temperature. I'm going to text Julian. I'm texting Julian. Can you guys, and Dave, measure the internal temp, of your setups while on and temp stable? Rough idea is fine. There. I gave them an assignment. As soon as my phone decides that it'll send out a text message, which who the hell knows when that's going to fucking happen. I have to be literally standing outside in order to get a text message out. But maybe, just maybe, they will give me an idea of what the internal temperatures are, how bad it gets, because there's a whole thing in the data sheet giving me a circuit that temperature compensates their 2164. Cabin Tech is a really good supplier of these things. I'm just closing these so that I don't have all these windows open. Put it outside the window for WindowCat to use. It is like 10 degrees out. Hold on one sec. What's the outside temperature? 33 degrees in the sun. 20 tonight. Ugh. Yeah, 33 degrees Fahrenheit out there. So yeah, I could hold it outside for just a little bit. 33 millivolt per dB control voltage law is essentially set by transistor physics and has the property of being proportional to absolute temperature, or approximately 0.33%, so 33 millivolts per dB, 0.33% per degree Celsius. If you're cold, they're cold, bring WindowCat in. I have not seen WindowCat for multiple years. And by the way, nobody in this neighborhood owns cats. So WindowCat was coming from some other house. WindowCat is probably very warm by a fireplace right now in some giant mansion that's like miles away from here. Not to say that I don't miss window cat, but I think maybe the smell of dogs probably keeps cats away. Low enough to be unimportant in most applications, but can be reduced with external temperature-dependent networks. And then they give us just like a loose example of a temperature-dependent network. I'm sure there are other circuits that one could use in this case in order to temperature compensate. But do I need to worry about that? That's one of the things that I'm like, because a lot of these modules that I've been looking at, these 2 HP modules, not necessarily from 2 HP, but the 2 Eurorack sized modules have like heat sinks on them and stuff. And I'm like, wait, this needs a heat sink. Do I need? Excuse me. Craziness. All right. So anyway, back to getting distracted over absolutely anything. I've got a value of the 2 resistors here. So we need to set these up with these resistors, 29 and 37K. And the debate in my head is whether or not, like, oh yeah, the other thing is when I double up, here's the kicker. Inside of the V2164, instead of making these high resistance, high Z, they decided that these pins would have an equivalent resistance, which means they require a certain amount of current in order to get them to work. Which means if I double them up like I am here, I need to provide a scaled amount of current input, which means the calculations that I've done for one individual pin are off. They're wrong. They're completely wrong. And so they suggest that you buffer it. You put in a little unity gain buffer in the line of your current controls, which I guess means we could stabilize it as well, but that means that there needs to be an op amp in there, which here's an op amp, and here's a resistor that can go from one end to the other through 10K or 1K. So does that mean that this is okay to drive everything to a particular voltage level? Or do I need to go with 3 individual things? In which case, these come in packs of 2 and packs of 4. So I would need 1 pack to cover the 3 knobs, and I would have 1 amplifier left just sitting. It happens a lot. That actually does happen a lot, but that would mean that I need to have 1 that's just kind of like, hey man, what's going on? It's not doing anything. Ridiculous. It seems like a waste when we're pinching every single square millimeter on this board. I'm probably going to try to use 0603 resistors and stuff, which makes things a little bit big. 0402, I can do. I really don't want to. I want this to be a little bit more friendly to work on than my experience with the mutable instrument. So anyway, we got to get to testing. We know what our deal is today. We're going to build more of this circuit, and we're going to test it. I feel like I need more overlays here to kind of explain out all the stuff that I just told you guys. I need like a scrolling paragraph, but then people will just ignore it and just ask me what's going on. So let's turn the scope off for just a second here and get the 29 and 37 kilo ohm resistors. Now, these are already here, so I'm going to leave them. Those are set up nicely, but now we need to do the R and the L. I'll leave this to volume, I guess, but then that means I need to move it. All right, so I'm going to move it up. So let's see. That coming from there. We may need to put another amplifier circuit here. So let's do that there. Oh, here, hold on. So we have, this one is coming from, move that over there. -12 to here. And then this is 3 pins. And we're using the front end of this one. That goes there. Then this one goes to +12. And it's... oh, wait, I did that wrong. It goes here. Square pin goes here. Because it goes, yeah, from here to here. So there, tuck you, throw you down, so that you go to that side pin. And that center pin is our output. So you guys need to move in 1 or 2. Luckily, so I added these headers to this. This is sort of the breadboarding 101, is that if something doesn't fit properly into the breadboard, you break out the square pin headers. Because breadboard is really made for square pin headers these days. You know, you can see these are squares. So you throw some square pin headers in, and then you figure out how you can anchor down your device. In this case, I clipped these short, and then I just soldered them big time onto this cheap-ass metal. This sort of sintered metal, it's not really sintered, it's sort of like, I don't know, it's just got a very obvious grain structure. Very cheap. I don't think it's coated. It's just very cheap solderable metal. It's what you see in a lot of the hardware of electronics. It's just cheap stuff. So you get these close enough, near enough as makes a difference. Give them a little coat of soldering, and you just go ham with the solder and just make an entire thing that will grip this and keep it from popping out. So now I can actually adjust these on the fly without them popping out and going all over the place. But now to add to that, we need a couple resistors. And since my resistor stocks favor surface mount, we are going to get a couple surface mount resistors onto this board, and we'll just fix the resistors for these, so we don't need a bunch of potentiometers involved in our day-to-day. And we'll see how these go out of tune too. That's one of the things I'm a little concerned with, is like the statistical variation between these devices. It feels like I could probably make a variable voltage range potentiometer circuit. Well, let's look that up actually. Before we commit this simple circuit, maybe we can find something that'll make a pretty precise variable voltage. Variable voltage circuit. And the easiest way to do it is to throw a potentiometer across 2 voltage supplies. Yeah, I guess that's pretty much what we're going to find when we Google that. And then sometimes there's adjustable voltage regulators, but I don't think they go in the kind of extreme range of voltages that we need. So I don't think that's really a good solution. Yeah, we're just getting power supply. I mean, could you take an LM317 and put one on, or whatever, a very small variable range voltage regulator? Can you put a knob over it? What do you mean? Over what? I guess there's not going to be much room for knobs. Let me tell you that much. We're going to use the knobless pots, and I've got a couple of these in a bin somewhere. We're going to use this style. Because if you look at the 2 HP modules, this is the easiest way for me to show you guys the form factor. Somewhere around here. Yeah, this picture. This is what a majority of them look like. Any of this style of Eurorack module is going to look like this. And they often have 90-degree circuit boards on them in order to hold the big complex circuits. But in my case, I am pushing myself to try to get this design just on that backing so that we can get cheap circuit boards. We can get real cheap circuit boards in order to make these. Yeah, the 2 HP is into this whole min-maxing thing. The thing I turn on the proto board, yeah, I could put a knob on it if I want. I don't want to have to. I don't want that extra layer of complexity. If I did like a voltage regulator, like an SOT223, that doesn't really save me any room over an amplifier, though, to be honest. It's actually doing the same job, and it's the same form factor. Like here, this would be the smallest voltage regulator that I could put to this task. And what we're looking at right here is a singular op amp. This is an SOT235 op amp, and I could put 3 of these down, but one of these could also do the job of all of the regulation of the 3 channels. one of this could do 3 channels that are this size. So the voltage regulator idea is just dead. It's just dead. I might as well just put more of these QFN packages on here. I don't know why I keep convincing myself to do things that are different, because god damn it. I mean, I could put it between 2 Zener diodes. What Zener diodes? Wait a minute. Let me look at what the Zener diodes that I have are. A while back, oh bother, went on the internet and he bought binders full of components. And one of the first ones that he got was a mistake. And that mistake was Zener diodes. So now I have a bunch of Zener diodes. Let me see. Let's try to chain these things together and see if we can do a Zener diode circuit, and maybe that would support what we're trying to do. Because if I can have one like voltage input, I can just have something hold it at the 2 voltages. Then I don't need the buffers, and then I don't need the entire chip. Oh yeah, some of these are not greatly labeled. Well, there's the 12-volt one is on this one. That ain't right. That's the last one. It doesn't help when all the labels are falling off. Where's my double-sided tape? I'm gonna put a piece of double-sided tape on all these. We gotta fix the shop as we use the shop. There's the double-sided tape. Always have that handy. Are you still there, Gonad? I'm actually curious if you have access to Nightbot. I can see probably not. I don't think all the moderators have access to Nightbot. I think it's only Short Lurker does. I was gonna say we need to enable the spam protection, and I don't get blamed when people send 15 messages in the span of like 30 seconds. I think we need to limit that a little bit. I mean, I don't get a lot of chatters, and I don't mind if your chat fills up the whole screen. That's awesome. I'm happy to have you here. But we had a situation the other day. Okay, so that's going to repair this. I do need to find out, like, I need to get more of these binders, because these are awesome. This double-sided tape is so hard to work with. He had a tornado warning? I don't think Shorty is, like, I don't think he drops into my streams at all. Short Lurker exists as a safeguard against me going crazy. If I go crazy and start spouting, like, all kinds of weird fucking opinions and stuff, and, like, everybody hates me, then Short Lurker can be activated as a sleeper agent in order to take over my channel and keep myself from ruining it more. Because I trust him. That's mainly on the Discord. And that was originally Octoj. Like, Octoj owned the Discord, and I was like, look, if I ever go insane, like, you can nuke it. I'm not in danger like a lot of these other creators of going fucking insane. I've been streaming for 10 years. Sleeper agent engaged. Okay, so we got to follow these logically. 27 and 30 volts are on that page. This one starts with 24, so I'm willing to believe that this is the sleeve that goes here. I've been meaning to do this for a while because the labels have been falling off, and I would very much like to know what Zener diode I'm pulling out. That one doesn't cover the whole thing. This is like the application for double-sided tape, isn't it? So this one ends on 8V2. This one starts on 24. Huh, what page does it go to? Maybe it does go to the first page. But that would make sense. Wait, hold on. These both start at 24 volt. 4, 22, 16, 12, 2v4. We've got 2 blanks, and I've got 2 sheets here, and I don't know what the order is. See, this goes 2730, 2730, 8v2 to 24. I would guess that this is going to be 8v2 to 24, and then this goes from 2.4 to 7v5, and then this one also goes 2v4, 7v5. There's a pattern. I recently watched a YouTube video, what's up, C. Strachan, on the LM431 adjustable Zener. Have you ever used them before? No. I don't do a lot with adjustable power supplies. I don't do a lot with that. This is sort of my foyer into voltage adjustment. I've been doing a lot of digital, like, you guys are wondering, why does Bother not know what the fuck he's talking about? Like, he doesn't know a goddamn thing that we've been working on. How is he so inept? How does one accomplish that? And the reason is because a lot of the stuff that I do is digital. We do a lot of digital stuff. We're very clever when it comes to digital things. We are getting into this world of analog, and I'm a little bit out of depth here. Because typically, when I would have like a knob adjusting something, you would just calibrate it in software. And so you would put your V minimum would be ground, of course, because everything is digital. And then your V max would be your VCC. And so you just put a potentiometer between the two. This one's way off, but whatever. You just put a potentiometer between the two, and, you know, Bob's your uncle. It's like really fucking easy to get a full spread of analog values into your digital system. And if they outputted wrong, you would calibrate the output differently. Like these advanced VREFs that I have and everything, like these are all new to me. So what we're going to try to do is boil our voltage system down to that sort of thing without using a whole chip to do it. We're just going to use a Zener diode. And we'll just see what happens when we try that system out. I just had to define all of my Zeners, and let's hope that they're correct. Otherwise, we got some binders to rearrange. All right, so half a volt we don't have. That kind of sinks it for me, actually, to be honest. I mean, I can put the 3v3 in, but I need half a volt. And then we could reference it to the negative 12 supply. But 0.6 volt doesn't really work. Damn it. We could regulate it to 3v3, or we could try what they have, what their circuit is. Where is that? But theirs was just to one individual channel, and I want to see whether or not if their circuit was locking it to, I think it was 8 volts. This is the SSI 6124, so it's very similar. It is pin compatible, but it might not be fully compatible. The control might be a little bit different in this one. 0 to 5 volt linear control circuit. We're not looking for that. We are running from a knob, as is a typical Saturday night around here. 12 volts, 840 ohms, TLV431A. What the? Oh, temperature compensated. Exponential voltage to current converter. What the hell? Like, I'm just trying to design like a scrappy little circuit that's going to control these volumes. And I got to deal with all the weirdness of your stuff. This is filtration. Generic CV driver. Negative 10 volts. Now, we've worked with negative 10 volt supplies before. And that would be a voltage per octave input. But if we make this, what are D3 and D4? Practical application of the above-mentioned filter stage usually calls for a physical control potentiometer and/or voltage input, signal scaling, and some protection. The circuit figure in figure 16 takes care of this and can be used for driving one or several filter stages. So we're going to have 3 of these if this is going to be the way we control it. I wanted to use Zener diodes in order to give us that voltage level control. They seem to think that we need buffers. This is a little bit more complicated, though. This one uses a negative 10 volt reference. That would make it accurate, I guess. So if you want fine tune, R3 could be replaced by a trimmer. A 1 volt per octave control signal could be fed into the inverting input through a 100 kilovolt resistor, kilo ohm rather. The ratio between R1, R2, and R3 determines the scaling, and if accurate tuning is required, R3 should be replaced by a trimmer. C1 filters unwanted noise for the control signal, allowing the SS to reach the best performance. Diodes D3 and D4 together with the op-amp make up a precision rectifier that prevents negative voltages from reaching the S blah 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 control pins. Yeah, but like, could I set this up as a voltage reference and then have my 3 go between this and another voltage reference? That would mean min-maxing this part, and I would still need 2 op-amps. I might as well just put 3 in and individually tune them. That is not... What about a... So obviously a 500 milliwatt, a Zener diode probably exists for 500 millivolts, seeing as everything else exists. I just don't have it in my repertoire. Do I have a half a volt voltage reference? I have some zany voltage references from other people's projects, so let's just see. This becomes yet another component hunt, where it's possible that I solve my problems through retail therapy. That's half an amp, but it's still adjustable. 5 volt, 1 amp LDO, adjustable. 5 volt SOT323 is obviously not what we're going to use, but I mean, we're just going to take reference from it. 1 amp. I'm looking for the fixed sources here. Shunt resistor, shunt amp, crystals, SMD pots. All right. Here are the big boy references that we use in the modular synthesizers. 2.5 volts is easy to find. 10 volt. Low sensor, 3-axis accelerometer, resonators. Yeah, so I think I got rid of the really silly shit that I used to have. Huh. Oh, let's not leave it at that. I'm sure there's others. Those are all the op amps. DACs and other digital stuff. Triac, MOSFET, transistors. Okay. Connectors. LEDs, gate drivers, singular op amp. An SO8, what a waste. More clamps and components and stuff. Hex inverter, potentiometer. What is that? Dual? Oh, it's potentiometer control. 10K digipots, other digital stuff. Max 308s. All right, so yeah, no, I don't have a part that's going to do this. Recently watched YouTube on an LM3. Oh yeah. Sorry, I already read that. Yeah, I mean, the idea would be that I would get a Zener diode, 2 Zener diodes, and if one is a half a volt Zener diode, then I could make that my 1 voltage reference, and I would treat it just like a power supply. And I would have a half a volt on one, and then I would have 3.3 on the other, and then I would just send that as the you know, set the reference to the amount of current that I would need to run the 3 potentiometers, and then that would be that. I would just, you know, have these silicon voltage supply making things do the work for me. we can test that with my power supply. Let's test that with my power supply and see if one influences the other when we double up the channels and stuff. So instead of this setup, and we still have it written down, so I'm actually going to keep these on the board. I'm just going to move them over. I will set the 3 of these in parallel and see what happens when we hook up multiple outputs to them. And we'll use the power supply as our voltage reference for now, which can later be set to 3.3 volts and negative half a volt. So what I'll do, because this means I need to purchase Zener diodes in order to test this thing that I came up with in my brain that would save components 2 little glass capsules as opposed to an entire op-amp setup. I don't know if this would be temperature compensating either. I'm gonna just have to, when I'm done designing this, I'm just gonna have to build it and lock it in like a heating chamber and just see what happens to the adjustments. These chips have been an absolute nightmare to work with. It seems like they were engineered to be as annoying as possible. So we set these up in parallel, and then I need my 3 power supply leads that we had been using for Eurorack that I hoped I never would need again. But here we are. At least they're free to do this job. And then so it's negative because it's the weird looking one. This one is ground. This will also tell us how much current we need. If I use 10 kilo ohm potentiometers. Why use 10 kilo ohm potentiometers? I don't know. Generally, you can put a 10K across your inputs and have enough current to run stuff. Hopefully we do. I guess we need to determine whether they're going to be 1K, 10K, or 100K. Zedner? Stupid Brits. Stupid Brits. How do they say it? Do they really say Zedner diode? That's stupid. Oi, Gov. Oi, love. Can I get a Zedner diode? What the fuck did you just say to me? Always the maximum amount of pronunciation in that language. How can I get more pronunciation for my pronunciation? All right, we're just going to use like the same size wire in order to spread these things out a little bit. Oops. Oops. We don't have the dog down here. He doesn't like me yelling. All right, one like that. The other one. We're just going to parallel these guys. Parallel. What we're trying to do is minimize. That's sort of the sacred task here, is minimize the overall footprint in terms of circuit elements that we need in order to make. Actually, I'm going to save the oranges for the next jump. We'll do the yellows for this jump. That'll get these a little closer together for my R and L, or channel 1 and channel 2 RL adjustments. And then the third one is a volume control, which still uses this chip. So we've got all the same stuff applying to these, it's just they all go to different circuits. Unfortunately, we have to use this third row here to do this. It's a really inefficient way to jump horizontally like this. And I guess I could have done it. How would that have worked? No, I don't think there's any super clean way to do this. Oops, no, that one has to go here. Ugh, come on. There we go. Oh, that's not going to work. Hold on. Nope, not there yet. Go from here to here. Oh, wait, this doesn't even need to, this shouldn't even be here. Get out of here. That. Probably a neater way to do this, but we'll just do it this way. Okay, so now we've got all those rows lined up. Now we bring in our powers over here, and I give yellow to the positive, white to the negative, and then blue to ground, because these are all referenced off of ground. So we do ground to system ground. I am playing the part of Zener diodes today will be my Agilent power supply. Just kind of horking up the amount of current that we need in order to keep these voltages stable. And so negative will go to one end, positive to the other. And we won't use our, what do you call it? We won't use our op-amp setup because the power supply is going to tell us how much current all this stuff uses. So let me get these out of here. The only op-amp that we need really is this one. We'll leave these others hooked up just for the sake of it. Okay, so now if I power it on, nothing's really going to happen. Let me get the Agilent supply supplying these guys with the current that they need, and then we can get a readout on them. So let's put the scope back up and just do a quick little sanity check. And we're not inverting, so we do on the negative supply, we go to negative 0.5, 0.6. And on the positive, we go to 3.3. Okay, so now, if I measure this, I get my scope over here. I put that on either of these. Our power will then go from, and we can probably zoom in on this. Okay, wrong pin. Negative, this says 400 to 3.3. That's very clean. But this got a little fuzzy down there. I don't know why it's fuzzy down there. It's a weird thing. So this is the voltage range that it appreciates inside to its control inputs. So if I'm running that, and how much current is that taking up currently? Not a lot. Okay. I take that and I put it into one of the control inputs, and we observe the waveform on the output over here. So I put this here, and we turn on our system. This may be the way to go. Zener diodes may be the way to go. And I'm going to do this control output here to our first channel over yonder. And then we're observing that dual channel. We go from very clipped. The sawtooth wave clips a lot to nothing. Clipped to nothing. And we'll check its buddy over here. The other output. That goes from maximum, not clipped, to nothing. It's either nerf or existential dread of absolute nothingness. Big bang, pre-big bang. Big bang, ball of energy. Big bang, ball of energy. Now we're getting into that theory where the universe is going to start shrinking in a couple billion years. Okay, so that gives me a really stable voltage level, and it's controlling both channels. So I'm starting to get behind Zener diode theory. Let's add the other controls in and see what that does. Now this is simulated Zener diode theory, so perhaps the end result is going to be a little bit different. Why are you not? There we go. That plugs in there, and then we can move our observation over to this side. We can take a look at this channel. Whoop! All the way to distortion and back. Do I want to let it distort like that? Not sure. I don't know if I want to let it distort like that. Oh, sine wave into square wave. Ooh. Then we go all the way down. Hey, look at that. And so we can individually control all of these channels, huh? And I am not even drawing an amp. That is a milliamp, and that's, I think, within the margin of error. Yeah, I think we need to put a 3.3 Zener diode on it and a half a volt Zener diode backwards to get negative. Negative 600 millivolt Zener diode. We would basically just be running this in the opposite direction. That just means that a lot of the voltage is going to be dumped to ground, isn't it? I don't know how much current that's going to do with a Zener diode in there. Because yeah, what's happening is on anything above 3.3 gets dumped through the Zener diode. Is that going to be way, way too much current? I don't know. I need a half a volt Zener diode. DigiKey to the rescue. Zener diode. Singular. I mean, it would be cool if there was just a diode array that had the positive and negative, but I think these are very specialty. 750 millivolts is as close as I think we're getting. Means our volume can turn way down. That's interesting. So nothing does negative half a volt. Do we get 500 millivolts maybe? 600 millivolts? Nope. They put it in actual order instead of just text order. Two results. Oh no. Zero. Obsolete part. God damn it. Putting a whole adjustable PSU on this task is not exactly something that I would like to do. Putting some kind of a voltage divider on it. MILFs. Hot Zener diodes in your area. I need half a volt because of the way that this thing turns down. If this thing goes to 0 volts, I don't think we can turn the signal all the way down to 0. Metal end leadless frame. What is that? Is that a type of? Oh, that's what that package is called, a MILF. I see. Yeah, those are fun because it's like you've soldered something forbidden to your circuit. Let's get a measurement of this. Control voltage. All right, wait a second. That's half a volt. Metal electrode leadless face, not leadless. Sorry, I'm reading it wrong. Leadless. They said negative 600, but it seems like we can get away with half, or we could set it to ground, and then it'll just be all the way down to 0. Let's try that. Let's do, turn this off. Let's make a little 3.3 volt regulator, and we'll hook it up instead of the PSU. so, oh, that's resistors. Wrong binder. My God. Put that one away. I need more cameras. Need more cameras on this setup, and Logitech's won't do it. I think some really crappy, like, RCA video camera dealies and a mixer would be a lot of fun to do, because then I could do like weird views of like the shelves and stuff as I look through them. One day I'll do that. I have enough little camera mounting things that we could have some pretty fun views, and I could have a little bit more like camera switch and action going on in here as I do the different tasks. Nothing would be unfilmed. It would be just like a weird angle. Okay, so Zener diodes. We need basically a 3.3 volt regulator on this thing. We don't need a whole 3.3 volt regulator. We pretty much need a 3.3 volt voltage reference, but we don't really need a 3.3 volt complicated voltage reference chip. So what I'm going to do is I'm going to use a Zener diode, and all that's going to do is make our 3.3 volts. Actually, let's hold on a minute. Power supply goes back in. Let's find out what our upper limit is with 10 volt input signals. My only fear is that all of this stuff is going to kind of shift. As I build the final circuit, this stuff is going to just be different in the end. I don't know. Like, where do these start distorting? But what the Zener diode is going to be able to do is give it a varied amount of current. It'll be able to just keep those reference levels solid as we move around. And it'll be one component. Oops, did I not hook up the other one? Well, these are on here. Okay, why are we using up a lot of current? What's burning up? Nothing's burning up. So, no, that's the signal. Is it supposed to be the other way around? Oh no, I guess that's correct. Why is it only going millivolt to millivolt? 3.3 coming in here. This positive pin. Did hooking up the full system nuke it? Or is there something about the way that these things function? No, this should go all the way up and down. What did I plug in wrong? Ground is on ground. Oops, that was bad. No longer has the full adjustment range. Huh? Wait, everything that I was just testing just went to crap. Oh, but I still have my full range. Was I just measuring the wrong thing? I don't know. Yeah, like here's where it distorts. Why is that going in a weird way? What's going on here? Oh, Vmax is 3.5. Oh, I see. Okay. Okay, I've got it right. Okay, hold on. So it distorts here at negative 16 millivolts is not where this thing is. What? Minus 60. Why am I getting weird values here? What I'm trying to do is measure the voltage that this thing is putting out in order to control this. Am I just not getting the voltage from that pin? It may be my breadboard. Vmax C1 is at -6, -4. Jiggle the wire. Jiggle the wire. Jiggle the wire. Nothing. Oh. Did we unfuck any of the issue? Very briefly. Very briefly we did. I'm trying to measure what the voltage is right now, because right now we've got our maximum sine signal here, right before it starts to distort. Not scientifically right before it starts to distort, but generally right before it starts to distort. And I'm trying to find out specifically what that voltage level is. When I poke into here, it completely dies and doesn't give me that voltage level. If I get this out of here, I have millivolts, which is not right. It's not correct. The full range of adjustment is positive to negative 3.3. Is this just at its least? Is it at its most? So that's like negative 60 millivolts, right? So now I turn it down. Until it's ostensibly not there, which is just about here, I would say, loosely. Measure that voltage level. That's the, okay, so it goes in opposition to what voltage level you have. This is 1.5 volts. Hold on, let's take that out. Yeah, see if the resistor's in there, it changes. 2.7. So around 3 volts. So I can do ground to around 3 volts, and I think it would be okay. The breadboard needs more cheese. Something. I don't know what the deal. Well, it's that. So it's the properties of the chip itself having a little bit of resistance that's really messing me up. So if I give it a 3.3 volt supply and reference that on ground, I think I can get these to work properly. So let's get the whole power supply out of here, and let's make a 3.3 volt Zener diode setup, which is easy enough. We can just get the 3.3 from right here. LL34 ZM 3.3 in its, what the hell is that? It's a MELF. Let's get our MELF out. And I'll find a 2-pin socket that I think is blank. There's one right there. So basically, we're using the properties of a transistor in order to hold it at a particular voltage. Now, the thing about this is that this transistor, actually, we should use the 3.0. Let's use the, well, we could try both of them. One's a 3.3 volt and the other's a 3.0 volt. Did I just get another 3.3? I did. I said, let me get a 3.0, and then I freed another 3.3. Dumb. This one goes away. So it's not to confuse me. We'll just see if 3.0 tightens it up a little bit, because it went from 2.7 volts to like 50 millivolts. So if we do ground and 3 volts, then we'll have a tighter range of values. Yeah, we're putting together a charcuterie of electronics. From Wegner's. There you go. We'll start with the 3.0 and see if that's good. And then if we don't get our full range, then we can throw in the 3.3. With the 3.0, if there's still audio visible there, I really should be listening to this instead of doing it this way. This has solder on it. Wait a minute. That's rejected. When I was working with this the other day, I put a bunch of the sockets over here. But that was for the voltage resistor divider instead of using a Zener diode, which I think is the much more cool play. This is the 3.3. I'm going to put that over here, and we're going to get the resistor off of this one, hopefully without destroying it in the process, and then put the 3.0 Zener diode on it. Instead of doing a resistor divider, which is essentially what the potentiometer becomes in this configuration. It rolled over on me. Jeez. Seems as though I need to remove solder from one of these to get it to work properly. Maybe reusing these is not the best idea. They are only pin headers. Boy, that thing looks beat up. A little glass tube with some contacts on the ends. He's just a little guy. God damn it. These you got to be careful with, because if you manhandle them the way that I typically do electronics, you can kind of mess things up for yourself. You can break the glass. I can't get it to sit flush. I don't think I'm going to try. Yeah, the sample books are really nice for organization. Really helps you keep track of everything. It's a very clever idea. Is that soldering, or is that just sitting on the top? There we go. Now it's nice and flush. I have a feeling the plastic of the header has been completely destroyed, but getting it to sit flush was a challenge. I should start with new headers instead in the future. Okay, so there's our 3-volt Zener diode. So we're going to use that and put it into our circuit. Now, do we need anything else in a 3-volt Zener diode circuit? DC input voltage from rectifier smoothing current. We have an RS that we need to figure out. Sometimes referred to basically the same, blah, blah, blah. We have a current limiting. So see, it's 0.7 volts. We need to limit the amount of current that goes through this. We were seeing on the order of tens of milliamps. I mean, we saw like 2.5 milliamp. That's what she said. All right, that works for me. Might as well take the joke from anybody else. Okay, so resistor RS is connected in series with the Zener diode to limit the current flow through the diode, with the voltage source VS being across the combination, blah, 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 stabilize output. It's like an LED. So small value in the series resistor RS will result in the greater diode current when load resistance is connected. And as large as this, we have 3 10K ohm resistors. So it's like a 3K. Right? Is that right? No, 1010 is, I don't know. Diode can sometimes generate electrical noise on top of the DC power supply to try to stabilize the voltage. Normally, it's not a problem for most applications. Yeah. Example number 1. Watts over volts, 2 watts over 5 volts, 400 milliamps. RS, VS minus VZ, blah, 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 17.5 ohms. We're going to try, I guess, a 1K. What are we looking at generally here? So what are they going to calculate RS for me? 4s and our clipping circuits. We're not worried about that. Yes, they do. It's very important that they are in the reverse orientation, because as your voltages change, you get to the Zener breakdown region in reverse. So the voltage of the Zener diode is where it suddenly goes and dumps everything as you're moving up in negative voltages. As you move up in the forward bias, it's just like a typical diode, and it suddenly gives way. but Zeners give way very steeply in the opposite direction, so they're used in reverse. So if we were doing a negative voltage, we'd have to really consider what the potentials are for ground and stuff like that. But a Zener diode is supposed to be in opposition to the way you would normally do a diode. If this were an LED circuit, an equivalent LED circuit, this would flip over, and so you would have all the same equations basically. That's why I'm thinking of it like an LED with only a couple milliamps across it. Whereas LEDs, you'd have something like 20 milliamps. This would have like 1, which is why I'm trending towards like a 10K or a 1K ohm resistor in the circuit path. So yeah, the band goes towards the band on the symbol. And so the band in this case, well, which way did I have this oriented? I had one of these hooked up to the output, which connects to the band. So I do one just like this. And then RS goes on this side, and we go towards positive 12 volts over here. So I'm going to do a 10K ohm resistor. And we'll see if that's able to power the three things. Yeah, blue line opposite the V. You just follow the circuit. This one's 4.7. So this is just a current limiting resistor. This is just designed to keep infinite current from going into our circuit. And so I'll take a 10K ohm resistor here, and I'm going to go from the output, which is on this line, to positive 12 volts, which is here. So we go from here to here. Is my thingy-wingy? Where's my thingy-wingy? Have you guys seen my thingy-wingy? It's in here. No, it's not. My thingy-wingy is out and flopping about. Just don't know where it is. I saw it a minute ago, but then I lost track of it. Happens a lot. I need to put magnets on this thing. Yeah, magnets would solve a lot of issues with trying to get my brand in the background. My brand! Oh, that's funny. I don't know where my little helper tool went. Scissors can go away. Typically it lives in here, but, oh, there it is. It's way back here. Yeah, and it's all due to the physics. It just has a better way of... It's not an efficient way of regulating, though. And I'm using it here because it's extremely space savvy. We literally have no room. So if I can make a very low current 3.3 volt reference, or in this case 3 volt reference, then we will have saved a lot of space, and the operation of this device will be just about the same. Of course, there won't be anything to do about tuning it. We can save that. I could put 0 ohm resistors on the legs, and then that would serve as a way to tune. I guess I went one too far. Oh no, I didn't go one too far. I don't want ground there. Oh no, negative 12 is, no, that's ground, right? This is positive 12 right here. So 12 volt going into the, oh no, that's wrong too. Where are my tweezers? I can't direct this shot properly. So this goes here as a current limit. And then any additional voltages are going to be dumped by the Zener to ground. So I need to jump these. And then we watch to see if the Zener gets too hot and explodes. Seat of the pants engineering is what's going on here. That's what you're going to get. And what this does is this severely reduces the amount of components that I need to achieve control through these potentiometers. This one actually I need to send just so it has a place to go. Okay, so yeah, that's it. That's all there is to the circuit. Now we just turn it on and see if we've got 3 volts out of this. And if it doesn't explode. Oh, good news. The circuit has been turned on this whole time. So we actively hooked it up to positive power, and we're not seeing a voltage out of it. Oh, wait, there we go. We are seeing a little bit of a change here as I adjust that. So there's not really enough current to power the 3 with a 10K. I got to turn off the power supply between these operations. Yano Cat! Hey, what's up, Yano? Thank you for subbing. Super duper subs. I wonder what the value of this one is. This one's 1K. Is that 1K? Brown is Brown and then Roy G. Biv, right? I'm not going to worry about it. I'm just going to make a new one. I'll just make a new one. I know, it's unheard of. He doesn't know his color code. My God. What have we created? But it's easy enough for me to just grab another 1K. I don't like through-hole resistors, but I have to use them in this. Once we solve this issue, we will then move to other stuff. We can kind of start the design. That's going to give this a little bit more oomph with a 1K. And that goes into, yeah, that leg of the thing. Comes from positive 12 volts. So turn this on again. You see barely a blip, but this thing is being held at 3.2 volts, which means that, oh, it popped out. That's the only problem with these pin header ones. So now we have our full range from groundish. Oh, you guys can't see. Groundish 3. Oh, wait, did it cut out at the very top? I think it cut out at the very top. Did it slip out, or is it a current thing? The diode is getting pretty toasty, or the resistor rather. I mean, it's getting warm. That's not great. This would be the maximum current going in. If it doesn't get any warmer than this, then I may be okay with it. And these are all held at 3.2-ish. And then our outputs are looking like what? Like nothing. Okay, cool. Oh yeah, because for some reason it's inverse. So if I take this and I lower it on, not this channel, on this channel. Okay, no, nothing. Whole lot of nothing. All right, so there's a little bit of a waveform. Oh yeah, these are all affecting each other. You see that? Yeah. This one is affecting the others. There's not enough current going through here to power all of it. And so as I adjust one channel, the channel that I'm not adjusting is moving around. Why is that one affecting the one that's before it? This is the one that I'm adjusting. So if I hook up to look at this channel over here, that's our square wave. So I can turn our square wave up here at the source, but for some reason I can turn it down at the volume control, which is not the stage that I should be adjusting right now. How hot is the resistor? Not above really skin temperature, like here. That's a little bit above. You barely notice it. Well, we can drop below 1K and see if that eliminates the change. Or, I don't know. 0 to 3 volts. If I drop a 3-volt regulator in there, I guess that might stabilize it. What the? See, not the channel that I'm on is having an effect on the amplitude of a signal next to it, because as I change these around, the amount of current changes that the Zener diode is supposed to be regulating. And of course, the current limiting resistor is limiting as hard as it can, but it's on 12 volts, so there's a lot of Zenering going on here. I was hoping this would have done it. What about a 3-volt regulator? I've got a 3.3 volt regulator here. Let's take a look at what that does. Let me just grab one out of the bin. But that means the project needs a 3-volt regulator. Let's just do this for the sake of doing it. Well, but what if I give it more current? Maybe it'll be quieter to its neighbors if it gets more current. These are 10-volt references. Those would be a disaster to put in. Those circuits, these circuits. Where did the 3-volt regulators go? We'll try to find them in a little bit. Hold on, we don't need to do this yet. Let's try a different Zener diodes in the art of falling off motorcycles. That was the Zen mechanic in the art of motorcycle repair. A human built this. There has to be a way to unbuild it. Sorry, Zen motorcycle repair guy, but that's not the case anymore. 820R. I guess that's what we're going to go with. We're going to go with 820R. We'll see if the resistor blows up. I mean, like, shouldn't this circuit be able to exist with 100 kilo ohm pots? So I don't know. I've lost my way. You know, we can use an op amp in order to constantly provide us with the current, I guess. I just didn't want to have a ton of buffer stages. I thought we would be able to run a couple of power supplies through knobs and have them not affect one another. How does mutables get around this? Power off. I got the 1K, put in the 800K. This is the one we're controlling directly. We don't get the full amplitude, though. Huh. This is not the one we're controlling. This is just messed up by the other one. And for some reason, this one just takes the cake. It just makes all of them go crazy. I'm baffled. I'm baffled about this circuit. I thought if we set this to 3 volts with the Zener, then that would stabilize the voltage for everybody. But as we go adjusting it, and look, as that resistor is heating up, we're getting less amplitude out of our circuit. What the? Yeah, we take up too much current. But like, I'm not using an amp. This thing was using on the millivolt scale because we're going through 10 kilo ohm things. Oh, you know what we didn't do? ground the other leg. Wait a minute, we're not referencing off of ground. Hold on a second. Wait a minute. We've got a flying lead. I guess it would be referencing off of ground. No, that's not wrong. Although hooking them up to one another is maybe the irresponsible part. Yeah, because we're trying to go from ground to the other. Yeah. Let me find a lead. Find a lead here so that we can hook ground up. It'd probably be a 0 ohm resistor just in case you wanted to like adjust it up a little bit in the final design. Yeah. So let me go with the lead that we're not pumping voltage into. So here we are pumping voltage. And so we're going with this far lead. So that would be over here. We hook up ground. Now we're properly set up. Okay, that doesn't span it. Where is the yellow jumper? Just a nice little sweater that I can put on. We're gonna just use whatever's on the, oh, here's something I can use. Gray. There. Okay, now we're referencing negative. Let's put back in the kilo ohm resistor. Well, let's just see if it works. Let's just see if it works first. This is with an 800 ohm resistor. So I did that while it was turned on. That was bad. Whoops. Mess with it, mess with it, mess with it, mess with it. I see a little bit of a whoop. Mess with it, mess with it, mess with it, mess with it. All the way up, all the way up, all the way up. That should be the least amount of current. All the way down, all the way down, all the way down. This would be the most amount of current going through this Zener diode. Why did you come back? I sent you to the shadow realm. Loose components. I'm just seeing if this gets too hot. I mean, 800 ohms seems pretty good. Yeah, we threw ourselves at ground and missed. That's what was going on. So what was going on is we had a bunch of flying leads that were referencing each other, and that became the lower limit. And so as we adjusted the other voltages, there must have been like weird leakages and stuff going on. But so none of these channels should affect the one that we're looking at, aside from the fact that I'm bumping the leads as I adjust around. And then this is full voltage. It's not quite. It is not quite full voltage. We could potentially get around this by having some kind of a horrific voltage divider by connecting the one side. Wait, what is that doing? Oh no, that's my ground. Okay. I thought I had a lead left in there by accident. So not getting all the way up to 10 volts on that. What do the other ones look like though? Oh, right, these are... they're not distorting, but they're not quite at 10 volts. We can solve that, though. We can solve that in the next stage. We can make that our maximum amplitude. What do our input signals look like? Oh, they look like that. What's my VPP? Where's my PP? 13 volts. 13 volts, huh? So I may need to adjust things in order to get us to our maximum amplitudes. 6 volts. Oh, VPP is 12. Yeah, so it's all about 13. That may be something that I can adjust with resistor values. Really, we should be, because our input is supposed to be plus minus 10. there's our input at plus minus 10. Input at plus minus 10, I mean, we could make this final stage. No, but that should be also plus minus 10. It's possible that there's a little bit of adjustment amplitude that this thing still has. You know, we're not adjusting it up to its max. What the? Where did the signal go? Oh, I'm looking at it wrong. I'm looking at it wrong. What? 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 Wait. What? What am I? What? What? Oh. Have a cup of tea. Have another one. Yoink, 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 yoink. So, okay. That, I guess, is that. Now we need to mix it up for volume. See, that my concern is that we're not getting the full spread of voltages from the 3-volt center diode. Let's put in the 3.3 volt, but that'll just make it go down. Because look, when I do the minimum signal here, and then we look at the voltage level, (1.4 volts. If I take that part of the resistor out of the circuit, boop, 2.5. (2.5), and we turn it up all the way, then we're closer to ground, but we're not close enough to ground. I think what's going on is see, we're at ground here. And it needs to go a little bit into the negative in order to get us to adjust it all the way, which means we need a negative power supply on this thing, and I'm fresh out of that. Unless I do something similar with the smallest value Zener diode, and then I would adjust I would put a resistor on the other end to work as a voltage divider. That means each one would have to have a resistor. Oh my God, my brain. Try that. Yeah, it's negative 600 millivolts is the lower adjustment of the. I thought we could get away with it because that end of the volume going low, but the problem is it's inverted. It seems like when it's at negative 600, we have the lowest. Let me bring 2 channels back on this. No, this shouldn't be that. When this thing is at, because what it's at right now is ground, right? It is at ground. And so the output here looks like this. Maximum. I don't know why it goes opposite. So that upper limit, that 2.7 to 3.3 volts, is this swing here that doesn't really seem to make much of a difference. Whereas over here, we're not getting to our maximum amplitude. This is what the output looks like. This is what the input looks like. We should look like plus minus, a healthy plus minus 10 volts. And instead, we are a plus minus 9 to 6, probably 6 volts. Yeah, Vmax is 6 volts. We should be 4 more volts into this thing. This should be a big signal. Because the only thing that's attenuating it is this thing. It's being converted back and forth to current. And maybe you could juice it up over here. But I want to get that upper end, and I don't want to have all this slop here at the bottom. That could maybe be heard. That definitely can't. And then I've got a full doot. That was like almost 90 degrees. That's like 30 degrees of travel there at the very end. That's just nothing. But when it's like when I hook it up to this has properties. This isn't like like when you hook up to an op amp, when you hook up to an optical amplifier, when you hook up to an operational amplifier, you're hooking up to something that's referred to as high Z. High Z means that it's got like infinite resistance between its pins and any other potentials. Whereas this thing does not operate in that way. It's really fucking me up, actually. This is really messing me up. The fact that when we hook up to this thing, it has properties. There's a certain amount of current that runs through this, and it saps away my voltage and changes it. So what I'm trying to do is I'm trying to set up a fixed voltage level that's going to, I guess, just react with the current as our upper limit. And then I thought I could take our lower limit as ground, but it turns out it needs to be a little bit below ground so that we get the extra punch on our stuff. So how can I achieve that little bit of extra punch without like adding more chips, adding more, you know, this, that, the other thing? If it's another Zener diode, I think I can deal with that. If I put in a negative, what's the limit here? Because yeah, putting in a higher voltage is not going to do it. I need a lower voltage so that the low is closer. So even putting a 2.4 or 2.7 volt Zener diode is going to bring down that lower floor. I need to bring up the upness and uppies. Why isn't this coming out of here? Jeez, must have been a break in the end. I had to peel this thing off of double-sided tape. Let's put the 2.4 volt regulator in there and see what it does. So we're getting kind of weird with the parts here, but it's like, I don't know a Zener diode that's going to let me do the lower limit. Oops, that was the wrong camera. Come back to me, you've passed out. How long were you there? Okay, it's weird that it works in the opposite, though. Why is it doing that? Is it something that I did? I don't think there's a configuration for it. They'll go through a control pin that goes through an amplifier, inverting amplifier. So what do they want for control on the SSI 2164, an equivalent chip? Same pinout as the one we're using, it's just a slightly different chip. Control ports, input impedance, gain constant, blah, 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 gain accuracy, channel mapping, maximum attenuation and gain. That's not what I'm looking for. Power supply, projection ratio, channel separation, operating temperature, voltages, supply voltages, mode, current, pin 1 to pin 16 via RM. What does that mean, mode current? Oh, that's the set mode, which is just the type of amplifier that it is, whether you want low noise or high performance or whatever. Typical application, RCCC, signal outputs, output current, control port. Provides exponential control with gain constant of negative 33 millivolt per dB. To realize the full gain relief, plus 20, plus minus 100 dB, control voltage should span from negative 660, which is really, really kind of a problematic number here, to 3.3 volts respectively. If only attenuation is desired, the control port can be driven directly from a low impedance voltage output digital amplifier, or digital to analog converter. And that's all they tell us. Negative 660 to 3.3 volts. So 2164 mixer. Most of the time, what these guys are trying to do is have a control voltage come in and influence that. So they will have a CV port. We don't need a CV port, so we don't need a 10 volt reference in on this. I don't have time to read about this with you guys here. Oh, I didn't expect us to have so much troubles. And so that's their little voltage regulator thing. I don't have the space to put a singular op amp on each and every one of these things. So what we're trying to design today is something that's lighter and just gives us, here's the upper voltage, here's the lower voltage, just like those are your rails, put a bunch of 10 kilo ohm resistors on there, and those will give us our swing voltages for adjusting. I could give us a plus minus 2.4 volt. What if I use the 3 volts as ground? How does that work? Wait, if I use the 3 volts as ground, that doesn't work. That doesn't work. Four-phase VCA mixer from Noisy Fruits Lab. Show me the schematic. They're not necessarily going to show that. Yeah, they don't. They just show you how things kind of go together. Stomp boxes, RFC, synthesis. Yeah, okay. So I got to think here. We can't find a half a volt. I mean, there are half a volt reference devices. I think I've run across them before. We could just run that in opposite. DigiKey time. Click on the images for what? Voltage reference. Yeah, the only problem is like single Zener diode as a voltage reference is kind of what I'm trying to get at here. It starts at 1.8 volts, unless there's like a millivolt category. Nope. Oh, well, I didn't see anything I liked. Yeah, negative 1.8 volts, but how would you scale in on that? What's going on here? That's just clicking stuff. All we get is negative 10. 0, 2, 3, 0.4. Here's 0.5 and 1. Why would it be what? 0.6? Can I get like a combo? 3.3 and... Nope. 20 for half a volt. Yeah, these are going to be SOT2235s, huh? Once I get that thing, which will probably be smaller than you would ever believe. Okay, so the question is, can these be run on a low side? This is adjustable. Adjustable, 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 adjustable. Adjustable, adjustable, adjustable. IC VREF Series 0. 000. In stock. Come on. Come on, in stock. Let's go. All of them are adjustable. What are we even doing here? 1 through 17 is 17, adjustable. I guess, okay, VREF. Wait, they've got these. It's Marketplace. Marketplace. Hey, Copper, how's it going? We're looking at parts because I can't figure this out. So, Marketplace product will never get here. It's from Rochester. Actually, that's a little easier. Let's look at the data sheet of this and figure out if we can run it on the low side. In, ground, out. Simple little package. Initial accuracy options, millivolt, blah, 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 blah. Reference voltage is 0.6 V. That would be our low voltage if we can hook this up upside down. Low voltage, high current, VRM, and blah, blah, blah. Accurate references for low voltage DC to DC converters. We're using it as a crutch. I feel like I'm using this the wrong way. Maybe just limiting these things with resistors, with the 30 and 40K ohm resistors is the way to go. I just wanted to save parts, because with the 30 and 40K resistors, I can't double up the output lines. With something like this, it'll try to keep that voltage reference at that voltage. Need coffee saying hi for being cool. You get your coffee. 2.7 to 5.5 volts. We can't use this. We can't use it. It doesn't take 12 volts. 12 volts is a big ask. So Zener diodes start out at too high of a voltage unless I take a, well, it would have to be another voltage divider circuit, which is getting absurd. It's either that or I do the resistors and I reference those very low current voltages with op amps, and then the op amp on the other end will be able to provide a stable adjustment, which is what we saw. Yeah, these can get expensive too. That's something I wasn't at the stage where I look at the cost. That's an instrumentation part, let's be honest. So like an adjustable shunt VREF would be too many components. Because remember, that right there, that component right there, is enormous on this board. Absolutely enormous. So yeah, no, yeah, no. Oh, this is discouraging. If I do it with 3 op amps, that's fine. If we take this voltage range as gospel, that would mean that a plus minus 10 volt signal comes in. We don't get a full dynamic range of our signal here. What's happening is I'm lowering the value of this. This is performing okay, right? This is pretty good, but I have all this slop at the end of my adjustment that's useless. I really want this to be an effective adjustment. And so to do that, I have to move it over on the number line, which means letting it go into the negatives, which means not referencing this off of ground here. Can I take like a big resistor, 10K? If we're going to negative 12, would we need another like 12K or something like that in order to get that to be in the right range? Then that's going to change. Oh, that's going to change a lot. It'll go 3.3 all the way down to, I guess, the voltage divider that this thing is providing with the current limiting resistor. Oh boy, how does that work? I can put a big resistor in and we can see what happens. There's all kinds of interactions that I don't know what they're going to do. So let's just throw a potentiometer in there. Let's just put a 100 kilo ohm potentiometer in here and have that be our ground lead. And we'll adjust it until we get the full range of values and hopefully nothing explodes. Turn this off. So we move our ground down a pin. Oh, damn it. Why is the... Okay. We'll move it to here. And of course it doesn't plug in, because nothing plugs in that easily in a breadboard. God damn it. So I'll put a 10K potentiometer here. Crookedly. And I'll put its lead to ground. The thing is, this would probably be mathable. I could probably do equations in order to figure this out, but here we are. Ground goes to this pin. I'm so done with this breadboard. I don't know if it's because of the way that it was built, but it's just so frustrating to use. I don't know. Yeah, I mean, needle nose, I could flatten the leads out a little bit better, but man, that's very annoying. And I think it's just due to the cheapness of the breadboard. Okay, so now instead of going to ground, oh no, this needs to go to -12. Whoops, daisy. So instead of going between positive 3.0 volts and we'll probably tighten that up a little bit with maybe with a 2-volt Zener diode, but instead it's going between 3 volts and wherever this is setting to. Do we set this by making it into a voltage divider? In which case, how does that work? That goes there. And this goes here, which is negative 12 is all the way over here, so. Okay. Is that going to be effective? Because that'll be like a buffer zone on the bottom of one of these. Are all these going to have resistors on them? And these are going to be, this line is going to be cut off. Because right now it looks like this. Yeah, this may be wrong. Right now it looks like. So these three are going to be offset biased by that -12, but then this whole not high Z thing is really bugging me. And maybe it is just better to individually give them references, but I don't know. We'll just try this. Let's just try this and see what happens. So turn this on. We're at low volume. Oh, this is the highest it goes. Okay, so now we can adjust this to be much, much higher. This is very slow going. There we are. We're at 10 volts. This will distort. Bring it back down. Now, what if I adjust this? Nope. No, that's nope. Okay. So that'll be 3 adjustments. That'll be 3 separate adjustments that change depending on, oh boy. That, okay. Yeah, okay. Uh-huh. Uh-huh. And there's all that extra range at the end. It appears to me as though my original circuit was probably the best. That way it can adjust depending on your preferences. And that would be this. Unfortunately, that means that we need 3 op amps in the circuit in order to achieve our goals of, minus all the way down to being quiet, and then plus all the way up to just before we distort. If I did 3 individuals on the thing and I cut the other 2 off, how many components would that be? That would still be fewer components. It would still be a Zener diode circuit. Let's figure out what the resistance is and see if we can throw in some near enough as makes no difference values and see what they do. It's going to behave differently when the other 2 aren't connected through that -12 connection, but we can just take these 2 here. We'll see. I mean, it may be that the other components are still going to be affected by each other. Yeah, it's the op amp that you don't use that you connect to itself that just does nothing. We're doing some pretty hardcore circuit stuff. I was hoping that there would be people who know about circuits in the audience, but you can never count on that. So 90K, let's add a 90K resistor to these and see what it does. 90K to minus 12. It's a big resistor. I mean, we're at negative half a volt. Yeah, not me, boss. I think you're going to say you're not my boss. That's another thing, is I can't expect free labor for projects that I'm essentially going to be selling. All right, 90K. I could throw 100K at it. It might not be quite what we need. 60, 75, 82, 150. Yeah, so 100K is as close as we're going to get to 90. Grab 3 100Ks. That means we may not get to full amplitude, but we'll get like a big step of the way. It'll probably be like 9 volt peak to peak. All right, so to put these to negative 12. So this one there, and then we are doing this leg. And so we go from that leg to minus 12. Oh, was that floating the whole time? That might have been floating. Oh, no, it got its ground from all the way over here. That's right. Yes, yes, yes. You are floating. And they're all at the break. That's hilarious. They're all at the break in the PCB where there's nothing in there. 240s. No, no, no. Why use less component when few component do? I'm trying to prove this out, and it's likely that this isn't going to work. The whole voltage reference and then big resistor to ground. Big resistor to minus 12, rather. So I'm getting a near equivalent resistance and hooking it up to the whole circuit, and then we can see where that fails us out. That's been kind of the way that we've been working on this today, is we just kind of see where it fails us. How are you going to fail me? Please describe. Enter your resume and then enter it again, and we'll get you in here for an interview, but we're not really going to hire you. We're just going to hire the manager's kid. Well, we need you to answer a question. If you were caught with a bear in the woods, man or bear, which would you rather have following you while hiking? Man, bear, pig. This is all my ADHD brain can handle. Also, hello, Chester Willard. We've gone through a few iterations of this, and the main thing that's screwing me up is the fact that the voltage control input on this chip influences the voltage of a resistor divider network. Because it's not high impedance. Unlike myself, it's not high impedance. That's impotence, not impedance. Okay, so because of that, as the resistor values change, the circuit's going to change. And it's really messing me up, which is why you want something like an op amp that is going to be set to a certain voltage gain to see that voltage. Oh, I'm not pumping in enough current. Let me pump in more current, instead of something that's sort of like calculating it with current. All right, so let's see how this does. So lower limit there. Oh no, so 100 is way too big. 100 is way too big. A little distracted thinking about how to make a fan tester out of a RP2040. What do you mean, like a fan tester? What, like one of those little propeller johns that lets you... Oh, yeah, you mean just send out a PWM signal. I actually ended up buying a little servo and fan. Does it do fans? It might. Do you have a Flipper Zero? I bet the Flipper Zero has that too. Although these are all highly overpowered things that I'm mentioning. All right, let's throw in 75 and see if that blows everything up. Ow. These things are like needles. Oh, PWM tester, but that has network connection. That's a very specific thing. Yeah, I guess there's your RP2040 project. Damn. Plug that. Put this in. Yeah, the RP2040 being $5 is like, I always forget that. I go, RP2040, that's too powerful. And I was like, but it's $5. That just like breaks, it just breaks everything. Why these thin leaded resistors are absolutely frustrating with this board. Because I don't want to cram the wire in between the clip on the wrong side of the clip. I don't want it between the sidewall and the clip. I want it to be in the clip thingies. But it ends up getting into the sidewall because it's so thin. Absolutely the worst. All right, so this is with 750, and we're still looking pretty shitty. Why would it still look the same bad as before? I'm trying to give it more voltage in the negative. So I'm doing a smaller resistor. And if I get crazy, I'll give it a 68K. We were at 90 kilo ohms for the 3. But I don't know if I saw any difference between this and the other one. 68K. This is, I think what's happening is there's other circuit interactions that I'm not considering here. I'm not bothering to figure it out in my head. I'm not doing the loops. Unless I got it on the wrong pin. No, I didn't get it on the wrong pin. That was the correct pin. Okay, all right. Come on. Okay, so that middle one means we're looking over here. Turn it on. Okay. That's still about the same, isn't it? So it's not allowing it to dip the voltage divider closer, further in the negatives. Oh, is that just moving it up? Do I want a larger resistor? How does that? What? Wait a minute, what? Hold on a minute. Oh, because if there's just a, no, but it's to negative 12. It's not to ground. This is to a big resistor to negative 12. Am I moving away from my goal? I'm at 1.4 volts here. If I did just a straight up connection, hold on, I'm going to isolate this control port and put it over here. And I'm going to take this away. And then I'm going to just straight up put a, well, no, putting straight up a wire over there is not the desired effect. I got 90K on that resistor. Maybe I measured the wrong side. If I put a 10K on this thing, which is way less resistance than we were originally thought for it to be. I think maybe I just measured the wrong side. If I put 10 kiloohms on this, that'll be significantly less resistance, and that'll allow it to go more negative as the resistor swings from one end to the other. It's getting worse. No, we're fine. Just don't cry. Don't cry. Don't tell mom. It's okay. It's okay. It's okay. It wasn't that bad. It's not that bad. Okay, so now we are at -4 volts. -4 is not, so that's 3.3 all the way down to -4. 10K is not the correct value. Want a little bit more than 10K. -4 volts is getting a little bit crazy. I got 22K, 47. Let's try 47. I have a feeling it gets a little non-linear. Oh yeah, this isn't hooked up to the chip right now. We would have, the chip would not have been happy with -4 volts. Did you guys see that? It went up. So this is positive 600 millivolts, which is getting very close. Positive 600. We wanted positive 50 millivolts. Well, oh, not really. We kind of want it to go into the negative just a little bit. If it was negative 50 millivolts, I think it would be okay. But negative 600 is where this thing should be going. Right now, we are not quite getting there with 47. So 2233. Well, last 22 kiloohm. So let's try 33. Because I'm going to need 3 of these to test this whole thing at once. Where did that 33 go? 15. I have 39, but this is 47, so 39 I don't think will allow it to dip down. I saw 33. It was like mixed in here. 330? No. 320R. It's basically, it's going to be the resistor value that I don't have. All right, I guess we could just try 47 because I have a bunch of them. No, wait, no, we just did that. My brain no more. 75, 82. One of these is out of order, and it's the 33s. Because I don't see any 33s here. Where's the decade box? Let's get the decade box on this. That'll solve this. There we are. You come with me. You go to 10K. Well, 20K. Okay, and then that goes up to 3 volts no matter what. This goes down, and we should swap that for the... Wait, that is the 3.0. Why does it go so high? This goes to 3.3. I guess maybe we did put in the 3.3 instead of the 3.0. 3.0 would get us a little bit closer to the theoretical lowest point. There's just a little bit of wiggle room in there. But right now, we've got the 10 kiloohm resistor, 20 kiloohm resistor. If I put in 30, right now we're at Well, wait a minute, we're at negative 1.3. So 10K gets us to negative 3 volts. What the hell happened there? Hey, Incredible Mike, how's it going? What? But what about my resist? Maybe my resistors are wrong. See, the thing is, this whole setup is going to be resting on this resistor, and if it fails, we get a very unfortunate spike in voltage. But if I have too little of it, if it shorts, we get even worse. Negative 10. Negative 3 volts. Go up to 5. Now we're on the positives. So I want to get just a little bit lower. This is a very sensitive thing. It looks like 30 is about the value that we want. Oh, that's 31K. So that's 30K. 20K, rather. 20K gets us to negative 1 volt. So we definitely don't want... What about 27? Negative 4 to 6. So 27K. That would be down to an individual resistor on each of these setting the lower limit. And then the upper limit is set by a Zener diode to 3.0 to 3.4 volts. And that way we get our full voltage swing for controlling these things with just a knob. So right now we are at 27K. And so I need to see how many 27Ks I've got. I've got a 22. I'm going to have to make my own 27K for these. Yeah, that's 22. 39. That's not going to do it. All right, so let's make some 27K resistors. Need 3 of these things. 1, 2. That's not. I'm probably going to have to make a 3rd one. Yeah, those all have resistors in them. So 2 of these. What did 30K get us? That's only 3 more K. Well, 30K is putting us at negative 300 millivolts. I'm looking at the lowest math function on that right-hand bar is giving us our V max. Negative 300 might be a good place to be, though. So that's with 30K, which I've got a couple of over here. I've got enough to do this, so I don't have to do any soldering. Let's find them. So 30K is 30 with how many zeros? 30 with 3 zeros. I'll just put these empty ones right here. And then turn it off, and we'll get the resistors out of there, and we'll replace them with the surface mount resistors. We've made a lot of progress. My low component, non-buffered volume control is coming together. Would it be better with the buffers? Maybe, but the Zener diode is going to regulate 3.3 volts as long as there's not overcurrent. And since we're not really doing anything else with 3.3 volts, it should hold that lower limit, the lower limit of volume control, pretty consistently. And then conversely, if we have resistors resisting on the 12 volt, I don't know if that's going to cause undesirable effects. I mean, I guess we got to test it to see. This seems to be a little cockamamie, though, to be honest. This seems a little weird. I don't know if this would be a recommended way to do it. Our lower limit doesn't have anything limiting it except for a resistor. So that's a 30K right there. We can put that here. And then put a jumper. That also means that the resistances will be changing depending on heat. Pinch that in a little bit. Yeah, I'm just not totally sure that this is going to be a good time. We're trying it, though. That's the sort of the main point here. I need to try it in full fruition because then we can know if weird stuff happens. It would be a little bit better if I could somehow do a 1/2 volt Zener diode. This one's 40K, so we're not going to use that. Where did they all go? I had 3 pairs of these. It's a little weird because I'm voltage dividing one end and then I'm voltage regulating the other. Yeah, we're doing a Saturday today just because I'm here. I'm going to be here during the holidays, so we may do some closer to the holiday streams as people, you know, go home to loved ones and stuff like that. Mine are local. One more right in there. Let's find it. It's somewhere on the desk. I got a buddy who's in town that we're going to do dinner tonight. So I got to kind of keep an eye on what the time is here. We're not going to run over time. We still got plenty of time. So let's test this, see what happens. I need one more 30K. And there it is. Oh, it is. Hey, that worked out nicely. Ah! Well, now I'll never know where it is. Here it is. Yeah, how would the other like synthesizer people do this task? I'm basically letting it dip down into the negatives just a little bit by putting a big value resistor on the thing. I guess that means that it's dividing voltages between the 2 limits. Oh, I need white wires for the rest of this. Top one's got one, other 2 need them. What a weird system, huh? It would be kind of cool if this were somehow configurable and you could, instead of doing 2 stereo channels, you could like route them differently. Because that would just be a matter of like a Maxim circuit in there. Just put a muxing circuit on it. I have a big old knob. Big old chunky knob. That's what it's ground wire, or sorry, -12 wire. -12. Wait, what's this one? What? Oh, that's this. This is the variable resistor that we've now replaced with 30K right here. And so that, hopefully, when I flip the switch, oh, you guys need to see the scope. Chunky Nom was my college nickname. All right, yeah, you know, everybody's got to have a prison name. Turn this on. We get -300 millivolts, which is our compromise, all the way up to 3.3. And we should pull that top limit in a little bit, but we'll do that with the different Zener diode. So what that means is that when I take this channel, take my channel, please. I'll be here all night. And I take it into, oh yeah, this is the old wire. This bank here. Oops, that's the control port that I'm looking at. I want to look at this out here. Ah, there's all our... Okay, it went away. We lost it. We lost it. Please don't be that thing that where if I touch it, it's the wires in this breadboard that are really kind of getting weird. Our gain goes up to maximum without distorting. And there's our minimum, and we can tighten that up. See, from very low audio about here where it just settles out. settles out. From there, there's like that whole quarter turn I want to get rid of. So we get our full spread of values here. Yeah, looking good. Looking good. Let's get that. Which voltage is this one? Let's just test the voltage here. We'll just use the scope as a multimeter. 3.3. So let's put the other Zener diode in. Turn off our system just to be nice. Just because we're nice. We're nice guys, you know. We're not gonna mess with it. But we can put in a lower voltage diode in order to squeeze the voltages in just a little bit. And the other test is, hold on, the other test. This has no perceivable effect. Ooh, there's a little bit. You see that? I'm pretty much just talking to NBandit, but yeah, it gets just a little bit of attenuation there. Is that something that I can prevent? I don't think that's something I can prevent. That's what the sort of the rail-to-rail voltages were supposed to represent. I mean, the only other way I could think to do something to it would be to change this resistor value. Now that one's not getting hot, right? No. What the? All right, well, let's tighten up the Zener diode because the lower voltage Zener diode will be better for this thing. So turn this off. Spring arm. Well, NBandit and the lurkers, I should say. Always appreciate the lurking. Y'all's doing me numbers and it counts. These aren't the best headers for doing surface mount to board, but it's nice when you only have, you know, the surface mount part to use something like these headers and be able to have it. My only problem with it is that these tend to pop out very easily. It's those big chunky square headers that really these proto boards are made for. Just kind of poking down on it to make sure that it's sitting down flat on the header material. When I solder this, it might actually center itself. There. Try to hit both of them, and then the surface tension of the solder will center the part. That's just purely for aesthetics. On a breadboard setup, we really don't need it to be like that. But one of these is a 2 volt and the other one's one of them is 3.3 and the other, the corresponding one is 3 volts. I think 3 volts will take us all the way down to quiet. Oh, great. This is the one with solder all over the leads. That solder down at the leads is going to make it pop out so much easier. Hopefully it can be low enough profile that I can get this to plug in and actually make connection. Doesn't look like it can. Okay, so I need to do desolder braid on these. I guess these were soldered, like desoldered from something, and I didn't realize it. It's not going to work. I have to come down from above. Okay, fine. Leads vice. Just gotta not crack the glass. Haha, it was very hot. It was very, very temperature hot. Ow. Why are you holding on to heat so much? Jeez. Well, that's not making good contact here. Hold on. That'll make better contact. They need all of the lead space that they can get because of their awkward shape. Let's let that cool down for a second. I don't know why the soldering iron's set to kill today. I guess it's that larger tip is really, really good at its job. Oh, that nearly desoldered the the can. Oh my god. Jeez. A lot of current running through. Yeah, I set it to 666 degrees Fahrenheit, so it should be fine. It's just, I don't know, today it's day after Friday the 13th, I guess. Come on, sit down. There we go. Nice and easy. I know the pace station is very good. It was kind of a shock to the system to spend $300 on the soldering iron, but the quickness of the changes, the amount of heat that this thing can get into the tip, and the variety of tips for it being like $10 to $14 each is really, really good. Yeah, the 300 plus the maintenance fees are totally worth it. And, you know, it's got a light handle. It's not one of these handles where they put like a freaking screen in it. And it is just a soldering iron. It doesn't have profiles. You don't have to sign into it. And I can't believe that I have to qualify that on every single freaking device these days, but not having an account with Pace is actually going to keep me coming back to this soldering iron. It's American made. Well, even better than, hell yeah, America. It is the same soldering iron that a lot of different very good electronics shops that I know use, and so I bought the same one. They had some others. There was like Metcal and some other, you know, Japanese soldering irons that were pretty good, but this one was an easy buy for me. And it's, you know, I use the soldering iron almost daily sometimes, so I need something that's just going to always work as a soldering iron, and this does. Otherwise, I would be using your what is it? Those little handheld USB ones, because they're pretty good. Got some hot hands. Yeah, I got the thermal imager, and it changes the view depending on what the histogram of thermal values is. It keeps everything kind of the samey on screen. So if you have something very hot, everything will look very dark. Yeah, the Pine Sill is one of the contenders. I think I have the TS100 as well, but the TS80 I hear is a little bit better. But nobody sent me one, so I don't have a review of it, and I'm not about to go buy anything like that to review, to make just sort of blind reviews of products. What? Oh no, the end of my Hako clone fell off earlier. I need to order a new iron. Look, I mean, Pace is getting there for me, but you're not in America. So you can obviously, you can find a better one. I mean, you're at the professional level too. Wow, whoa, big cramp. Oh, whoa, 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 whoa. That was almost a very big Charlie horse that I just got. Ooh. my Achilles tendon almost balled up like a window shade. I only have a meat thermometer. These are the things that I like people to text me. I'm just gonna text, I only have a meat thermometer. Okay. Give me that schmeat temperature. Okay, let's turn it on again and see if we get a nice spread of values in the full range. Boop. Not quite. It's not that one, it's this one. So there's our full, and there's our, oh, that's pretty good actually. Yeah, negative, I am a meat popsicle. Okay, so this is, geez, the new circuit. The new circuit is weird. So relationship with this circuit has ended. This is our new circuit. And instead of So let me do an actual drawing of this just so that I have record of what worked today. None of this stuff, this circuit, of course, will work no matter what. And it may end up being what I have to do. But the circuit that we settled on today is kind of a weird flipper baby of the original circuit. So we have plus 12 going into, oh, let's do squares. 890 ohms. Hot. Into our Zener diode. Which one's Zener? Zener is, damn it, come on back here. Okay, hold on, let me just get my my brain together here. Don't need that. Don't need that. Glance. Okay. Now, interrogative. If I put the Zener diode to -12 and I gave it an offset, no, because it has different properties than the positive and the negative. You can press space and use your arrow keys. To do what? I ain't doing that. Do you want me to make the rest of this document to look like a professional schematic? Look at what I've been doing here. Come on now. You guys know the capacity under which I use paint. It's very, very important that I'm able to do things freely in paint. Straight lines my ass. Didn't you put 3.3 in? No, we just swapped it out for the 3.0 volt Zener diode. And that gave us a little bit better range on the bottom end. So that's 3.0 volts, and that ends up being our reference. I'm just going to draw it as like a big thing. We'll just make it a big thing like that. And then we've got our adjust here. Ooh. And then we've got another resistor here. This one's G. And then this is -12. And our resistor is, what was it again? 30K. Now, I was thinking that I could take those to one resistor. Like if I had a -600 millivolt Zener diode, which apparently I can't find, but if I had a -600 millivolt Zener diode, I could, or some kind of granularity in that manner, I could adjust that upper and lower end, and then they would be in the right spots. But it apparently just doesn't work out that way. And maybe there's a better way to do it if anybody can think of a better way, but I don't want to involve a lot of components. Our main limitation being space. See, if I try to go smaller, then it looks better. Just get back to doing my mouse stuff. There's nothing else there. Whoa. The only reason for that 30K is that we need to dip down into negative 600 millivolts. So it's positive 3 volts to negative 600 millivolts. Well, it's really kind of around 300. Around, oops. And it's like being able to have like a voltage regulator adjust to negative 300 millivolts. I could probably find an adjustable voltage regulator and put that in, but by that time, I might as well have buffered it with op amps. I might as well just have 3 different buffered op amps in there and just have the voltage swing be done by resistors and the potentiometers. And that's this over here. That's this scheme. If I was adjusting the channels individually of all 8 of the amplifiers, I could put this in there. But the really responsible thing to do would be to have some kind of a buffer on every single channel. So you'd have a unity gain buffer on each one, and it would just be a 30K and a 40K resistor on the top and the bottom. But that's 3 more op amps, and that's an entire new chip. The amount, my ability to fit 4 resistors and a Zener diode among the other stuff at the bottom of the board is a little bit better, because this can spread out. This can be spread out amongst other components. And if I need to tune that upper limit, the upper volume level, I can change out the 30K. If I need to change out the lower volume limit, well, that's down to whatever Zener diode I can source, 3 volt, 3.3 volt. And at least in the lab here, that gives me good adjustments. Why am I on camera? Who is in the booth? Can we get somebody else controlling the camera, please? That's the overall. So let's hook the rest of this thing up. Did I lose it? It's still on. I should be getting a signal. There it is. So see, all the way down until it's gone, all the way up. Now, to be honest, I am a digital guy. I do voltage levels. I don't do audio. And it might be that this level right here is somehow audible still. Or maybe my effective range would be from here to here. I wanted it so that I can't see on my scope in 15 volt peak to peak mode. I can't really see any kind of a volume on this until I get the first quarter turn, and then I start to see it again. In terms of like, what's that going to feel like when you're using it with audio? We got to get there. We got to get there with this. So the next stage of this is to hook up all of the different mixing elements of this. So let's turn it off. And now I need to send channels around. So each of these L and Rs, now it doesn't matter what channel we hook up to what right now. It's all going to be down to where I have left and right coming in. And that's going to change when we move to the PCB. So these channels are on the center pins. So I've got 2 channels coming out here, 2 channels coming out here, and we need to mix them together and send them to the next stage, which is going to be the volume mixer. So what I'll do is I'll get some tiny little jumpers here, some wee lads, and I will throw them in. Okay, and I'll throw that on the ground. And then we throw it on the ground. Yep, that's how we do it. It just clicked out of my tweezers and went into the cat dimension. Oh boy, there's so much stuff. That's a control input. This is our observation output. We're going to take that off. Put a control input here. It's good that I got away from the op amps in mixing the channels, because now I can fully utilize only one of these, because I need to invert the signals still. So I'll use those exit stage unity gain amplifiers in order to re-invert the signal so that it doesn't get like weird phase issues if you mix channels together in and outside of the mixer. Of course, the mix configuration would be a really fun thing to be able to mess with, but I'm not gonna, it's out of scope for this. But if we were able to take channels and throw them in like weird ways against each other, that would be something that like the digital element would bring to the table. And then those output right and left. So let's, I don't have red. I can use orange and white. Is left white or is red white? I think red is right. So that one will go into the input over here. We haven't hooked up all 4 control channels of the volume control yet. That's going to be the next challenge. So that goes into a control port here that is connected across there, and then we need to also connect it to the other side of the chip. So there. Yep, it's way too long. Way too long of a wire. We've made a lot of good success today. We've made a lot of progress in this. We'll get there real soon. Once I hook this up a little bit more, we can have more of an impression of what goes on behind closed doors. That's too short. What the? Can't win today. All right, red wire, you're going to be the right length. Wait, this is the control port, not that one. That's the outputs for right and left. The control ports are all going to be the same because this is an overall volume control. So I need a longer wire. Damn it. I'm using scraps on the desk. I need to use like better wire. Here's the big kit. That's not going to be long enough. It needs to be a little bit longer than that. I mean, the orange wire was my better bet, but it's too long. You bend the wire around and then it's facing a completely different direction. No, I can't see you. Can I feel you? Yeah. Let's see. That would be, yeah. So the right and left channel there. Wait, that's a control. What is that doing? Oh, that is a control. Yeah. Oh boy, we need to reevaluate all these connections. Let me just figure it out. Let's put all of the control voltages. There's the input, there's the control voltage. So that's right control. This one's left control. And these are the outputs here. And so the outputs need to come in to the inputs over here. And so let's get that finished up on the right channel. So the right channel is going to this one here. It's control signal. No, that's the wrong one. Up here. This is the output, the dual output there. That one's going into the shared ins of the entire side of this one. That one goes to the shared ins the entire side of that one. The outputs are shared here. These are the control ports. We need to go from here to here. So I need a relatively short wire, a pair of relatively short wires that are about the same. We'll just get it hooked up however we can. Even smaller. No, larger by 1. All right, that's that one. Now we need this one to this one. I could find another yellow wire, that would be great. But just for the uniformity, the consistency, so that you could, at a glance, go, aha, I know what's going on here. Of course, it means it's going to block over other elements. These are all controlled by the same control, because this is R and L coming in, but they're kept separately in the amplifiers. I could just use 2 amplifiers, but apparently you get, I don't know, better granularity by having 2. I don't know. I really don't. Okay, so there's that. And we have our control signal going in there, going to all of its places. And then our input goes to 2 of them. This is wrong, because our control signal goes in here. Goes into the second pin. And then the outputs here, we are going to observe, but those outputs are what we're going to put into the headphone amp. So the next stage of this is going to be messing with the headphone amplifier to get that to output a proper signal, and we can plug cans into it. I don't know if we're going to get to that today. Pin 1 and 16 control the mode, and so this one is our output. No, output R and L are on these. So these get the mixed channels. But sending 2 from the same side over is not what's supposed to be happening here. 2 from the same side. Hold on, let me think about this. So we're supposed to have stereo, and that's supposed to be 2 separate channels, but then one controls LR and the other controls LR. So actually what should be happening here is, it's fine. No, that's exactly what's supposed to happen. Okay. Because on the output, we should get LR1 and LR2. All right, let's see what the output looks like. Let's turn this sucker on. Bonk. Looks like nothing to me. There's volume. It doesn't do anything there. Yeah, so hooking up the 4 changed the dynamic of the circuit. It changed the circuit around. And so now we're stuck again where our Zener diode is unable to provide enough current to have this thing go to full value. And that resistor is actually getting pretty hot. So I think I'm going to end up needing 3 amplifier circuits on this. And that's something that I'm going to hook up in this weekend. So we have failed. We have failed. I probably need to check over the circuit as well. Let's see what's on the other side. Whoa, okay, wait a minute. The fact that it changes when I change that is a little disturbing. But wait, where's my mixed wave? It's gone. So something else killed it. Whoa, okay, that's not good. Why is that all the way at, oh, whoa. Got a couple gremlins. Well, let's not do that to our poor chip. Our poor chip. Don't do that to our poor chip. What are you doing? Oh my God. This would be the, yeah, this would be the input. That's a little messed up. Something is still wired wrong. I'm drowning by the light. No, I can't see you till I feel your touch. I mean, that looks okay. Should be all right. There's something objectively wrong with the channel, though. And it should probably cross over, and I'm not really sure how exactly. This one should be okay controlling multiples with 1, although what is that floating lead? Wait, oh, this is my test lead. Those 2 are the output. Oh, what's you doing? Control pin. Oh, this one's to there. Yeah, okay, that's the input. That's doubling up the inputs. And then control, control, control. Control to... This one's the control pin. Whoops. Nope, that's correct. Input, 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 input. And then the channels come in here. Although maybe this should be cross-mixed. But still, it doesn't matter because whatever channel is whatever channel. So if I bank them right and left bank, that's totally fine. And they are controlled together. And so we should be seeing 4 waveforms on the output. But instead, we get nothing. We get kind of an output. It's our triangle wave being like destroyed. Yeah, I think the only way that I'm going to get around this is to use buffers. We're just going to have to use buffer amplifiers on this thing. I need 3 amplifiers. I need to bring in another one of these tiny little QFN amplifier chips, drop that down, make 3 buffer circuits, so that's no extra components, and then each of those buffer circuits. How come we had it working so well before and then it just crashed down? I think part of it is adding that other chip's impedance circuits to it. I think it needs a significant amount of current from our drivers above what our 800 and something 890 ohm resistor is allowing. If we went down to 400, that would be fine, but that resistor is going to get really hot. So I kind of don't want that to happen. And I guess the dynamics of the 3 resistors in loops is affecting itself, and there's no buffering going on. So it's going to be much cleaner if I pull 3 more amplifiers in there. I wanted to make sure, because remember, the amount of space that we have to work with is ultra super duper low. We have 10 millimeter by 100. And so if I even just so much as brought in 2 voltage regulators to make the negative volts and the positive volts, that would really kind of cramp the style of the rest of this thing. Having just one of these amplifiers and a couple resistors near each of these would, I think, will be all right. It means that we got to route traces throughout the whole board too. We can swap around amplifiers and hopefully that won't noise up all of our signals, because we'll have basically 2 of these QFN chips. One of them will have a combination of, you know, the inverting amplifiers and the amplifiers that are required for the controls. So I think that'll work it out. Then it's basically just an analog negative to positive swing with 10K being our adjustment range. That's what I was thinking. I was thinking, like, could I hang that voltage range, negative 600 millivolts to 3.3? For us, it's a little bit more constrictive than that. It's like 150 millivolts to maybe 3 point something. So I don't know. Anyway, I guess that's all I have today. We didn't quite succeed, but we do know what I need to do next, and that's to buffer the controls through amplifiers, and that'll just solve all of our problems. That'll just, you know, sweetly solve all of our problems. I can get that done on the prototyping board. I'll have to bring in another op amp. And then another op amp chip, the combo chip. And then from there, I mean, it's just, you know, springboard into PCB routing action. We'll be able to figure out what the PCB has on it finally, and I'll be able to get the full schematic. I'll be able to get the full schematic onto the computer, and then we can see how much trouble we're in terms of laying this thing out. That's really where the things are going to get kind of interesting, is like, how am I going to put a trace here? We need to get the absolute maximum trace spacing and all that stuff worked out in the rule checker of the program, and then we need to kind of weasel our way into getting all of that stuff to route around the circuit board cleanly. It's going to be a hell of a time, but that'll be for the week. So I'll be back on Tuesday. You guys have been dead on arrival, but there's a lot of you. You guys are great. EU is better. Hooray for metrics. I can't believe I've missed little tiny comments here and there. You guys are great, and I'm sorry I missed your comments. We've been kind of with our noses down on this thing for a little while, making sure to get it all in. I think I'm finalized on the circuit. I know what I'm going to build. And by the way, the different values for the potentiometer mean that I can tune it after the fact. My only concern is temperature compensation. If my boys report back to me that the voltage or the temperature levels inside of the their modular setups are too much of a swing, then I need to think about that and think about implementing the circuit from the data sheet. But yeah, we've got hey, I'm lurking here. Hey, bada bing. Fitting these is also the SOIC chips, fitting them onto the board. That's going to be another one of the big challenges that we have in CAD. That's going to be a big challenge. So yeah, more big challenges to come. The mixer circuit moves on to the next stage, I guess, and I will do a little bit of testing on my own so that I have my test bed here ready to go. And then by Tuesday, I would like to start putting the schematic into CAD, and we'll have an AutoCAD sponsored stream. That'll be pretty fun. Until then, you can catch me in these links, my Discord and my quote-unquote social media. Bski. Every now and then I'll update Blueski with a little picture, and I'll say, hey, I'm a little guy. How you doing? But yeah, until then, I will see you. Thank you so much for joining me, everybody. Have a good one. I'm just gonna glance at who's streaming. I rated 2 people last year. It's mostly because you guys know where you're going. You guys know what's up. What's up, what's up, what's up? Oh, nobody's around. Big Clive. Everybody go watch Big Clive. I will catch you guys later, all right? Thank you for joining me.